Hey everyone, in this series we're going to look at how to make an updated version of the arcade classic Qbert. The main difference is that the original Qbert was in a 2D environment that was trying to emulate a rudimentary 3D environment. In this we're going to just use a 3D environment, and the irony is that the 3D environment is actually easier to use than trying to fake a 3D environment in a 2D environment. So let's get into it. So the one thing I've done so far is I just created this model in 3D Builder. You can use whatever 3D modeling application you want. There's nothing special about it. It's just kind of an oval, the nose, couple legs. I did have to shrink the scale factor because for some reason making models in 3D Builder, they come out huge. But otherwise you can work with that when you make your models. So right now, we're going to start with just the tiles that Qbert lands on. So we're not going to make a full block because it's really not necessary. The only thing that really matters is the tile that he's landing on. Now, the pyramid shape that he's on is actually much simpler to make than what it may look like because traveling down along the left and the right side, those two sides are actually, those paths are actually perpendicular. What makes them look like they're an odd angle is because of the positioning of the camera. So it makes it super easy to make the board. So I'm just going to rotate this around the director's camera. Haven't actually moved the player camera yet. So game object, 3D object, plane, it's too big, and the math, while it's simple, is very important. So 0.1x, 0.1y. Why? Because that makes it exactly one unity unit. So what's a unity unit? Well, positions here, we'll put this at all zeros. The difference between 0 and 1 is 1 unity unit. So that lines these up absolutely perfectly. So what we're going to do is we're going to have one path come out this way along the z-axis and one travel this way along the x-axis. So each tile will be successively 1 unit further forward and 1 unit down, and this will be successively 1 unit down and 1 unit along the x-axis. So let's see how that looks. So we're going to copy, we're going to paste, and what we're going to do is we're going to move this, as I said, along the z-axis, exactly 1, so -1, and down exactly 1, -1. Likewise, this one traveling this way, let's copy and paste this, will instead be 1 along the x-axis, stay 0 on the z-axis, and then I already had set the -1 for here. So already it's starting to look like the top of the board. And if I take our director camera and do that, it really does look like the top of the Qbert board. Before I go any further, yes, I absolutely could use the instantiate command. I could use a for loop and an instantiate command and do this with like 3 or 4 lines of code. But because the positioning is so important, I find that I'd rather demonstrate this visually than go through the instantiate code. Not to mention that you only ever make one board, so it's not like you're doing this times 100 or 200. It's whatever, 20 some odd tiles and you're done. So yes, you couldn't use instantiate, but I think in this particular case, because the layout is so important, I think I'd rather do it visually. Okay, so we'll copy this one and we're going to continue along the x-axis here. So again, it's just one more and one more. Likewise, this way, it's one more and one more. Now you can just go down, you can go along one side if you want. You don't have to keep jumping back and forth. So whatever makes more sense to you, so we can keep going in this direction. So -3, -3, -4, -4. Again, you're trying to keep a consistent slope to this line. -5, -5. So that gives us 6. And Qbert's board is 7. And so there's the 7th one. And then just rinse and repeat on this side. Oops, let's try that one. So since this one was 2, 2, it's just 3, 3. And let's try that again with the numbers I actually said, Mike. 3, 3. And again, I'm saying the absolute values. Some of these are negatives. So the y is negative. So 4, 4, 5, 5, 6, 6. So there's the border. We still have the middle ones to fill in too, but we can always do that later. Now I really want to focus on the control, but now you've got the idea of how to make the board, how to make the layout. So let's take Qbert and put him into the scene. Looks like he might need to be shrunk a little bit. So let's shrink him a tiny bit. Again, I think I mentioned already that this is kind of that I had to really shrink it because for some reason 3D Builder makes them huge. So let's rotate him up and then rotate him around. So it should give us a negative 90, 90, and a 180. Depending on what you use, you might not have to rotate yours at all. And we'll put him centered-ish. Kind of hard to center him exactly, though, because of his nose. So that's something we will have to take in consideration. The good news is that Unity doesn't detect collisions based on the object itself, but the collider box, which is unseen. So you can always make your game a little bit more forgiving by having the collision area not exactly match the 3D model. So let's do that. Let's go ahead and add a collider. We might have to tweak it later in case it's like bumping the ledges, but we can cross that bridge when we find it. So Qbert needs two objects. Two components. My apologies. Qbert needs two components. So add component, physics. There's the box collider. Obviously positioned wrong and the wrong size. So let's shrink this like 0.5. Actually, I was doing a test run earlier and I was getting some unexpected, he was hitching along certain tiles. So let's do 0.3, 0.3. The idea is so he's not just landing on these tiny little legs, that gives us more space to land on. And let's make this, let's raise this up like 0.2. Okay, so his legs actually extend beyond that a little bit. So let's make this like 1 point, rather point like 1.8. That's fine. And again, when we actually have him jumping around, if there's an issue with him clipping against, if he's hitting the board, we can always make this maybe a little bit more narrow. Like the X could maybe be like, say, 0.25, that kind of thing. All right, so what we're going to do now is we're going to add one more component. So the box collider, again, is for collisions. And then the next physics component will be rigid body, and that allows for gravity and velocity. And those two things I just mentioned are going to do the bulk of the movement. So right-click, create, C#, and we'll call this Move Q. We'll take Qbert, we'll add Move Q, then we'll open Move Q. Okay, the update section runs once per frame, or another way to say it, runs every frame. So what we're going to do is we want to look for input. So if, oh, sorry, my apologies. That should not have been an asterisk. That should have been a parenthesis. My apologies. If, parenthesis, input, dot, get key down. The reason why you do get key down is that this will be true for only the first frame that the key is down. So in other words, you want to do this as a non-rapid fire. You would use just get key if you want a rapid fire that every single frame it's true. Get key down is only the first frame that the key is down. And we're just going to use, let's use the A key, it doesn't matter. You can use whatever input you want. We can look at some alternates later on. At the beginning, when you first make a game, it's just prototyping, it's just proof of concept. You can always go back and fix things. Like, for instance, as of this recording, a couple weeks ago, Control by Remedy was released. There were some performance issues. This week, an update just got released to improve those performance issues. That's just the way game design works, is you continue to iterate. So you may want a different control scheme. That's great, but I don't want to bring the project to a grinding halt trying to look at all the different control schemes. So for now, we'll just use this one because it's easily provable. In other words, if I'm using an analog stick, it's like, okay, did I really press down? Did I press down left? Here, it looks for an exact key. So if input dot get key down, A key, then get component. What component? The rigid body that we just added. So if the rigid body component, if the A key is pressed, we're going to modify the rigid body velocity, and it's going to be new vector 3, which means X, Y, and Z in this case. So for this one, this will be moving along Z, so X won't move at all. We'll have jump 4 in the air of velocity of positive 4, and we'll have a -1 velocity. It's moving out towards the camera. Now, I could copy and paste this, but I just want to demonstrate this working. Okay, now obviously I need to move the camera for the player, but if I press A, see, you can see he's in the center. So we know that works. So because I'm lazy, but also to reinforce the idea that once you've done this, you're just going to rinse and repeat, we're going to add the W key. And this is going to reverse this. Since he's jumping up, needs to jump higher, so we'll make that 6. And we'll make this a positive 1, because rather than moving towards the camera, moving away. So let's save that. And we will move the camera now. We're going to have it match the, not exactly match, but put it close to the same perspective of the director's camera, whatever Unity calls it. Let's rotate this some more. Rotate this down. It looks like I might have positioned it a little bit too far over. And nothing really, no rocket science to this part. This is just trying to make it look right, trying to center the board. You know, zoom it in, zoom it out. Nothing really scientific about this particular part of the process. And you can certainly tweak it if there's something about it you don't like. Thinking it needs to move this way a little bit more. Yeah, that's what's wrong. Then we could rotate it that way and then rotate it that way. And it still doesn't quite center, but I seem to keep going back and forth, so I don't want to waste your time. So as soon as it looks close enough, I think that's good. Yep, not perfect, but he's not quite centered, so the pyramid isn't quite centered, but you get the idea. You just kind of have to play around till you get it right. So we said that A moves down. Now there's nothing in place that would keep you from hitting A repeatedly. So right now that would absolutely break movement. So we will eventually put a control into place that makes sure that you can't repeatedly hit A, that A will only respond once you've come to a halt. And then we said W is up. Obviously, it doesn't rotate. That doesn't happen automatically. You have to put in a command to rotate. We'll probably do that next video since I'm just handling the motion in this one. And now just rinse and repeat for this direction. So we'll use the D key for traveling down along the X. Now, because we were going positive in the X direction, it's not -1, it's +1, at least for moving down. But then moving back, it'll be -1. And this will be the E key. Now, when I was testing this earlier, for some reason, when he was moving up this way, he would clip and get knocked over. So if we have to mess with the collider box, I might do that between videos. We'll see if it works. All right, so D, D, and then E. Nope, just fine. Not sure it's my imagination, but it looks like he wobbles a little bit. So depending on the aesthetic you're going for, you might not like that. There's a few things we can do to make him not wobble. But again, this was just the start. This was just getting the basic motion in place. So we've already built a good chunk of the board. We've already got him doing his basic movement. Yeah, he is kind of wobbling a little bit. The base probably needs to be a little bit wider. Anyways, so that should do it for this video. So we've gotten the basic movement into place. We have a good chunk of the board in place. In the next video, we'll finish the board. We will have him rotate depending on which direction he's traveling in. We'll see what we need to do about the wobble, but again, it's not interfering with the game, so that's more of the debugging and optimization. I'll probably save all of that to the end as far as, like I said, how we need to put in a control so you don't if someone rapidly hits the jump button, it doesn't break it. So those kind of things will all be put in at the end. So the next video, though, will be he'll rotate. We finish the board. When he jumps on a block, the color will change. And checking to see when all tiles have been clicked on. So the next video will get us probably like halfway done already. Hey everyone, in this video we're picking up right where we left off, and that we are going to finish up the board, and we are going to have Qbert rotate based on which direction he's traveling, and we will also have the tiles change color when he hops on them. So let's start with finishing up the board. And so it's just more copy and paste. So what we're going to do is we're just going to like copy this one and then travel down, copy this one, travel down. That way we're not kind of jumping back and forth like in the previous video. So it makes it very easy to calculate the next position. So these are the ones that are traveling along X. So we're going to go 1X, and then it needs to move down, and then we'll just keep going. And so this would be 2x, -3. So again, you're just moving it 1x and 1y. And just, again, rinse and repeat. So increasing x by 1, decreasing y by 1. And yes, as I mentioned in the previous video, this could be done with an instantiate command. Maybe at the end of the video, I'll show an alternate way. But again, it's really not necessary. If you were going to make lots and lots of boards, then yes, you would want to use instantiate. But it's just one board, and once you've done this copy and pasting, you never have to do it again. And just like that, we're almost done. And there we go. Just like that, we have a map. Our board, whatever you want to call it. Okay, so we can test this to make sure he can hop all around, but because we again use the same proportionate spacing, it shouldn't make any difference, but we'll test it just to be safe. So we've got A, D, A, D, E, W. So yeah, this is just fine. Hops all around. Okay, great. Okay, a brief splice there. I had to test something. So as I said, we're going to rotate Qbert now. So if you look at the transform component in the inspector, you'll see that the current rotation is -90, 0, and 180 for X, Y, and Z. And that rotation works for the A key because we said the A key is what will bring it down to the left. So let's go over to our move Q script. And we'll just paste this in, and I'll read through it. So transform, so that's the component we were just looking at. Your angles equals new vector 3. Again, this just says that there are 3 different vectors that you're choosing, the x, the y, and the z. If this was 2D, it'd be vector 2. And we're using exactly the same settings that were there because, as we said, the A key will move in that direction and that he's already properly rotated for that direction. So now W is the exact opposite. It's moving up and to the right, therefore should do a 180, literally. So a 180-degree difference would be 0. Don't be like me and accidentally do -180 and fail at math, because obviously the difference between 180 and -180 is 360, which means it's the same thing. -180 and 180 would be the same. And then you just build from there. So D is a 90-degree rotation from A because that would be down to the right rather than down to the left. Again, we're working with perpendiculars here. And then E would be the opposite of that and therefore would be -90. Now, it's possible I got these two flipped. If it is, it's just a matter of moving the negative, not a big deal. And we'll just run this. Typically, I like to test as soon as I add new functionality, but it's clearly rinse and repeat as far as the rotation. So why run it through 4 times? I'm not trying to pad out the length of the video. I like these to be nice and short and snappy. So A, and then D should move down to the right. Perfect. And now the 2 ups, W should move up to the right, and E is up to the left. Absolutely perfect. So just like that, with just a couple minutes, we now have the rotation in place. So you've got the basic functionality now of Qbert in place. One thing that I didn't mention that the original game did have is there's also like a couple flying discs. We can add those later, but we'll do the same thing. It'll be like exactly 1 position over. That way we don't have to modify the control, and that will probably be one of the later videos that we do. Okay, so we finished the board, we added rotation. Now we are going to have the blocks change based on him landing on the block. So to make the tiles change color, what we're going to do is we're just going to create several different materials that have a different color. And then based on impact, what's going to happen is the tile will then change the color. It'll change that material. So let's right click, create material, and we'll call this white. And it's already white, so that can stay. And we can you can either duplicate the material or just create a new one. The only time you'd really duplicate a material is if it had a whole bunch of settings that you wanted to maintain, like you changed the metallic and the smoothness and whatever else. So to copy a material, just so you know, it's Control D. In fact, it's not just copy material. You can copy any object, just about any object. You can, sorry, I said objects, asset. Just about any asset you can select and then click on Control D to copy. In this case, there really isn't a need, but I just wanted to throw that out there so you know. And we'll call this one green. We'll keep it simple for the moment. And we'll click up here, and we'll make this whatever, a green. So now it's just a matter of having this material get swapped out by this material. So right now, this just has a default material. So this is something I probably should have done in the first video, because if I applied the material to the very first tile, once I copied, the tile would have copied the material with it. So now I have to manually apply the material. Not a big deal. Again, I don't want to confuse issues, so I was really focusing on the layout. But yes, to save time, you can indeed apply a material first and then copy. But as you can see, not a big deal. We can easily do these in just a minute or two. So again, I'm just clicking on the tile, drag and dropping. And almost done. And there. So now what we need to do is we need to make the tiles aware of the green material. So the way we do that is right now there is not a script attached to the tile. I'm going to create a script and attach to the tile. Again, that's something that you could have done at the beginning but I didn't want to go through the whole idea of scripting until we actually laid out the map. So we're going to make a script and then apply it to the individual tiles. So right-click, create C# script. We'll call this TileCon for tile control. Sorry, I'm not quite sure why this sign popped open like that. I've noticed that Visual Studio does that. It didn't even open to the new script, so not quite sure why it does that. But now we can just double click and open that up. So outside of start, outside of update, but within the public class, we're going to do public material, and we'll call this green color. Oh, wow, my goodness, caps lock we're on, sorry. We'll save that. Now what we're going to do is we select our planes. I probably could have done this with the material now that I think of it. You can select multiple objects and then just drag the object onto it. So like if I click on these individually, you'll see they all have the TileCon script. So my apologies, I should have done that with the materials. Had a momentary lapse of common sense. Just want to make sure that all the tiles have it or else something weird will happen. Although it'll be obvious because if the tile doesn't change color, then you know the script isn't on it. Okay, so the tiles now all have a script, and the script makes reference to the material. So you can again select them and drag and drop that material right in there. And now it's just a matter of changing the color based on an impact. So we go back to our TileCon script and we do on collision enter as opposed to on trigger, which you've seen me use in some of the other videos if you've watched any of the other ones. So this is when it's not a trigger. This is when it's a solid object. So what we want to do, first I'm going to change this. I don't like the fact that it defaults to collision to refer to the other object that's being collided with. It makes it look more like a functional term, whereas this reminds you that it is the other object in case you have to reference it, which is very common with triggers. So for the moment, we're going to say if there's any kind of collision, then the tile will change, but we'll have to modify that once other things can collide, once other objects can collide, like we mentioned, the enemies that will be bouncing around. But again, this is an iterative process. So we're just going to get component, renderer, material will be set to green color. So again, same type of coding we saw earlier. You're referencing a component, which component the renderer, what attribute or what part of it, the material, and what is it being set to. Now what will probably happen is the tile at the top will change color because as an impact we can put some coding to adjust for that because like I said at the beginning he basically drops onto the tile. So if nothing else, that tells you that it's working. He landed on it and it changed color. So we'll do that, and we will do that, and that, and that, and Hey everyone, so picking up right where we left off, we mentioned in the last video that in this video we are going to create a system that tracks how many tiles are remaining that need to be changed, and when all tiles have been changed, that is the level complete status. Now, I mentioned using tags on the individual tiles to determine what their status is as far as have they changed, how many times have they changed, and I realized that by using tags, it's going to require a whole lot of if-then statements checking the current value of the tag and then assigning a new value to the tag. So why do all that when we can just let simple subtraction and addition do the work for us? So rather than using tags, we're going to use a variable assigned to the tile, and that when Qbert lands on the tile, we simply subtract 1 from the current value, and if the value equals 0, then the global variable that tracks the total gets reduced by 1. And then say Qbert lands on that tile again, well, 0 gets reduced by 1 again. It's -1. It doesn't equal 0, and therefore the global value won't be changed again. This also works for when we have to jump on a tile 2 or 3 or 4 times. So we just keep increasing the starting value, and it also takes care of the issue with this top tile, because what we can do is we can just set this top tile, the variable that we're going to create, we increase its value by 1. So Qbert lands on it at the beginning, reduces it to 1. Now its value will match every other value. So 3 birds with 1 stone, actually. So let's go ahead and go to our tiles script. So we open that up. And what we're going to do, in the public class section, but above start, we're going to create a variable. So public int, and we need to give it a name. So we could do like color status, something like that. Color status, because it's not just going to be yes or no. It's an integer. So we save that. So this is attached to all tiles. So now all tiles have access to this variable. But just to be clear, it is not a static variable. So this variable is unique to each and every tile. So what we're going to do, we're going to click on this top tile here. Since it's a public variable, we can change it here. So just his or its value will get changed to 2. So it's not Qbert, it's the tile. So that way when Qbert lands on this, this will be changed to 1, and all the other ones are already 1, and it will match that. So now what we're going to do, we now need to do just a little bit of math. So when the collision occurs, and again, right now this is not checking to see what's colliding with the tile. Eventually we'll have to modify this, but we really can't do that until we've created the enemy. So there's no point trying to make this future-proof. You create a system that lends itself to iteration. And if it doesn't, then you just uproot it and you recreate. So color status minus equals 1. So that means take the current value and minus 1 from it. So we always want to minus 1. If color status equals got to do 2 equals when you're checking. If it equals 0, then we do this. Now, that really won't make much of a difference for what we see other than the top tile. I don't think we really need to run it just to see that change. But now we need our global value to also get changed in here. So let's go ahead and create a new script. You can create, usually when you have variables such as static variables, and you have functionality that's not necessarily assigned to any one object so much as the overall game flow, then what you can do is you can create a script and attach it to an otherwise unused object, and that way the script is executing from there rather than from any of the actual in-game objects that are in play that might get deleted or whatever. So game object, and we could just do create empty, and we just got to rename this to GM. So again, there's absolutely nothing special about a GM object. You're calling it GM for your benefit and your benefit alone. It means nothing to Unity. This is just going to hold the new script. So C#, and we'll call this game flow because that's, like I said, is what it's going to do. And then we open it. So here is where we have to create the static variable. In fact, I'm just going to delete these two remark lines. When you see that double / it's a remark, which means it's not executed. You can use it for documentation, or you can use it to hold code that you're temporarily suspending for some reason. Has no functional use. It's just documentation. So above start, above update, but within the public class, we're going to do public static int, and it's going to be remaining, if I could spell, remaining tiles. And it's going to set to 28. So we are actually incredibly close to having this system in place already. Now we just have to reduce this when a tile changes, and then put in an if statement that says what to do when this is reached. So actually, let's do that. In the update section, let's just do if remaining tiles equals 0, then we want something to happen. Debug.log quote, you win. So that's just going to show up in the debug log. In other words, we need that to test that this is actually working, since we don't actually have a screen that says you won or, go to the next level. We need to test this somehow. So you'll probably find yourself doing this a lot, putting in a debug log just so you know something's working. Also, what you can do is we could do debug log and just put this in there to see that it's changing. Okay, so now what we need to do is we need to reduce that. So if color status is equal to 0, then we need to do game flow dot remaining tiles minus equals 1. So that should look familiar. We just looked at that. It's saying take this variable, whatever it's equal to, minus 1 from it. Now, because it's a static variable, we have to declare where it is. Whereas this is a variable specific to this object, we don't have to. Whereas this, we're reaching out to another document. We're reaching out, to another script and pulling it in from there. Okay, so color status should start at 1. When a collision occurs, it gets reduced to 0. If it's equal to 0, then remaining tiles get reduced by 1, and the color changes. The next time the tile gets land on, it will be -1, and therefore none of this occurs. I think we can run this now. Okay, so let's go ahead and attach the script, and let's run it. So that didn't change, so far so good. So now we'll just, and my apologies, this is going to be a little bit slow. We don't really have like a turbo mode or anything yet, so That one changed. And it should appear down here. Perfect. So obviously we don't have a new scene to load, but that's the basic game. So it now checks how many have to be changed. It knows when you've reached the end. And the next step will probably be to add enemies. That's going to be a little bit trickier. There's probably a good AI to come up with, but the AI wasn't really fancy back then. For instance, a lot of the enemies would just drop down, kind of like a slinky. So you'd have like a blob that would drop, drop, drop. And it may not just go down the side, it may kind of go back and forth, weave back and forth. So that we can do through randomization, just using a random number generated to determine does it drop left or does it drop right. Now, the ones that actually track you will be a little bit harder, and I'm not going to speculate until we get there. I don't want to put my thumb on the scale and be wrong yet again. But we'll come up with some rudimentary way of having the snake, that's the one that chased you, having him run around. But for now, and a brief splice there, I had some audio issues, so sorry about that. You probably just noticed this appear down here. This is just me saving the scene. So to do that, you just go up to File, choose Save or Save As, and name the scene. That's actually essential for the final task that we're going to do in this video. So I just mentioned that we don't have another level to load, but what you can do is reload the same level, so at least you see how level loading works, and then once you create a second level, you just got to swap out the name for the new level you've created. So once you've saved the level, you need to go up to File, Build Settings, and you need to add it up here. So this is going to be included in the final build when you turn this into an executable file. You would just need to delete anything that you don't want up here or add new levels as you've created them. And you can also use it in this case for testing, because the command that we're going to use only works if the scenes are in here. Okay, so you save the scene, add it to the build settings menu, and then what we're going to do, we are going to go back to our GameFlow menu, our GameFlow script, my apologies. Have to reopen it because, like I said, I had some audio issues, so I had to restart. So outside of the public class, we need to add a new line up here. So using Unity Engine dot scene management and then a semicolon. Because if we don't do that, it won't understand the commands that we're about to use. So right now we say that if remaining tiles is equal to 0, display this on the screen and then really nothing else. What we're going to do is we're going to say that we want Unity to reload this scene. Now, what we're going to do though is typically when you're at the end of a level, you don't just automatically load the scene. You have some kind of screen that says, well done, here's your stats, how long it took, any bonus. So what we're going to do is we're going to create a delay. That way it's not jarring. It doesn't just suddenly load the scene and they think that it crashed. So outside of start, outside of update, but within the public class, IE numerator, and then we name it. And we could go just call this load next level with parentheses, squiggly brackets, and then it will be yield return new. Now, typically I like to explain what every line every word does. Don't worry too much about those. You do need to include them, but really what you need to focus on is this. Wait 4 seconds. So we're going to say how long we want the application to wait, measured in seconds, before it then performs the task that we want it to do. We'll just do 4 since there's really nothing for them to see. It's not like there's a scene complete menu or anything or a tally. So this is just for demonstrative purposes. Okay, so now this is the command I was talking about. So scene manager dot load scene, and I named it level 1. And then up here, this does not execute automatically. You have to say when it gets executed. So we want this to execute when remaining tiles equals 0. And so we just say start coroutine, parenthesis, and then the name of that coroutine we just created, including its parentheses. So again, when remaining tiles equals 0, we still display UN like we normally did, and then it starts this coroutine. It comes down here because you just told it to. It waits 4 seconds and then loads level 1. So once you create new levels, this is the only thing you're going to have to replace, this one line. All this other functionality, this all stays the same. The only thing you would change is what level is being loaded. Okay, so that should now run, and that should now work. Let me just double check. Yeah, because this is the step I usually forget to do. I create the coroutine and then I forget to reference it. All right, so this is going to take probably, I don't know, a minute or so to color in the blocks. So my apologies. Maybe you could just like skip ahead in the video. Or I mean, I suppose you could just take my word for it, but I like to demonstrate that it actually works. Oops, wrong way. Wanted that one. And there we go. So that should do it. And actually, I did make one mistake. See how he bumped like that? Do you know why he's doing that? Because it's reloading, reloading, reloading. And the reason for it reloading is because this does not get reset. So we just need to reset that. So basically, before you load the new scene, you just set remaining tiles back to 28. I'm not going to run it again. We saw that it worked. So even though you reload the scene, the static variables do not reset. So that should do it. Hey everyone, so in this video we are going to begin to add enemies. So what we're going to do is first you need to create a 3D model. I made this in 3D Builder. You can use whatever you want, and there's absolutely nothing special about it. There's no controls attached. It's just a 3D model. What we're going to do, we're going to have the GM script be made aware of this 3D model and spawn it on a timer. And then this blob object will get its own script that then controls its movement. And basically it's just going to use a random number generated to decide is it going to fall left or right, left or right. That's it. Okay, so let's get into that. So first thing we're going to do, we're going to open up the game flow script. And up here, we are going to make the GM object aware of the blob by doing this. Public transform, and we'll call it blob obj. Now, I like to use the suffix obj when I'm naming objects. That way I know when this shows up in a list that this is specifically an object, because particularly when project gets longer and you have more and more variables and methods and things like that, you really want to make sure you can distinguish the naming. So now, right now this is just an asset. We need to turn it into an object. So we're just going to drag it into the environment, and there it is. We can kind of just move this so we can see it. So this, just like the other 3D object, I had to shrink substantially. Depending on what modeling program, you might not have to do that, but if you do, I just want to throw that out there. So we're just going to rotate this 90 degrees. Nope, negative 90. And because it doesn't really have a front, we don't have to worry about rotation. It's going to look right no matter which direction it drops in. Now, in Qbert, this is animated. We can look at animation later. Again, this is just about how you spawn the object, and you have the object have basically give it rudimentary pathing. So we have our object, and now what we're going to do, we're going to take this and we're going to put it down here back into the asset area. We're going to create a new prefab. Going to delete the one that's in the scene. And so what happens is this one is the one that's going to be spawned. And we're actually going to add a few things there. We're going to add a script, like I said. We can always do that after the fact. We don't have to do it before we create the prefab. So we have our object, and we want it to be able to be spawned. So we go back to the GM object. There's the blob object. We just take blob and put him there. And then what we do, we are going to create a timer so it gets spawned at a certain consistent rate. And what we're going to do is we'll use a variable for the amount of time, at least eventually. That way, as levels progress, you can simply shorten the time in between them being spawned. So how do we do that? Well, we already looked at IEnumerator, so just creating another IEnumerator. And this one will be spawn blob. And even though it's underlined, there's nothing wrong with it. It's just saying that there's nothing in here. So now what we're going to do, we're going to do very similar to this. So yield, return, new, wait 4 seconds, and we'll just do 3 seconds. But like I said, we're eventually going to replace this with a variable. That way it spawns faster and faster. So we now need to instantiate an object after the 3 seconds have passed. So when you hear instantiate, that's the command to spawn. So when you hear instantiate, think spawn. We're going to spawn the object. So instantiate, 3 arguments. What's been instantiated, which is the blob obj. Where it's being instantiated, we're going to instantiate it. This too could be a variable because you may want it to spawn in different places. You might want it to spawn up here. You might want it to spawn here, here. I guess we'll just do the top. So what we'll do is we will have the spawn above 0, 0, 0. We'll have it spawn like just above it. So this is also a vector 3. So we just said 0, and we'll do like, say, 0.5 F, so it's just above that tile. Actually, no, we want it to actually drop down from above, so let's do like a full 2 above it. If you use a decimal, you have to drop an F to let them know it's a float. If you're using a whole number, you don't have to do that. And so that's the second argument. So again, what's being instantiated, where it's being instantiated, and then the rotation will use the blob object's own rotation. So instantiate the blob object at 0, 2, 0. And now that we've created this, we need to call it, because just as in the update section, we need to call this one, we also need to call this one. So we're going to do it outside of the if statement, of course, though, because it's not dependent on remaining tiles. We just want this to be done every 3 seconds. So let's actually put this in the start section, because this would be, even though there's a 3-second delay, if we put it here, this entire section gets run every frame, which means every single frame it would be doing this again and again and again. So let's actually put this in the start section. So let's do start coroutine, and this will be spawn blob with parentheses and a semicolon, not an apostrophe. Sorry about that. And then what we do, we go back to our scene, we go to our blob, open prefab, and now we're going to start adding a few components. Right now it doesn't have a rigid body, so it would just spawn up there and do nothing. Can use the default settings. We want gravity to be applied. We might eventually freeze the rotation. We'll see. So let's run this. Let's just move him. Okay, so it dropped, but it went through it. That's because it does not have a collider. So what we do, we go back to our blob, and we go back to that, and we add component and physics, and we're going to add a box collider. So what we do, I'm going to edit this collider, and you don't have to use a box because it's roundish, but for our purposes, this is fine. It's not using really precise. So I could lower that bottom a tiny bit. Okay. So now it has a box collider. So now when it lands there, it'll stop. So let's bring him down. Perfect. Now, obviously, we don't want it to change the color. We mentioned that in the previous videos that we're going to have to put a control in place that right now the tile changes unconditionally, that if a collision happens, it changes. Now we're going to have to check for what's colliding with it, which is fine, but let's get the pathing done first. I don't want to get distracted by that. So for the pathing, as I said, we're going to add a script to this object that controls it moving left and right. Just like Qbert, the difference is it'll be automated. So let's right-click, create C#, and we'll call this blobcon. I'm not sure if I will use the same script for the other enemies. That's why I'm making a script specific for the blob. Sometimes you have different enemies that they appear differently, but they move the same, control the same, so you can use the same script. Don't think that's the case this time, because the blobs don't chase. Again, they're just kind of tracking down like a slinky. So we're going to, again, click on our blob object, open prefab, give it that blob con, and then what we're going to do, we're going to use movement that's basically identical to what Qbert does, because it's a very fixed location movement. It's not like as we discussed, it's not like a regular 3D game where you can run around in little minute controls or little minute increments that you're having a very fixed location you're moving to. So right now we use negative 90, 0. Sorry, that's the angle. My apologies. We're using 0, 4, negative 1. So for it to move down along the left, this is what we need to replicate. So let's just actually copy that. So we go to blobcon, and we don't want this to happen as soon as we want this to be based on a collision. We don't want it to happen as soon as it's spawned. So what we'll do is, again, we'll do on collision enter. And again, we get rid of the word collision here because it looks like it's a functional word when in fact it's referring to the other object. So what we're going to do is when the blob collides with something, it will then move. And that automatically gives you your timing. Now, it's possible you may not like that. It's possible that you say, no, I want it to kind of hover for a bit so we can look at putting in a delay. But again, it's an iterative process. You start with the basics and then you build on it. So this means that when this blob, so the blob will be instantiated, and when it collides, and the first collision will be the top tile, it'll then start jumping down. Because this will keep happening. Every time there's a collision, it will jump again. So you don't even have to, like I said, at the moment there's no timing. It's based purely on collision. So there's no pause or hesitation. If I haven't forgotten anything, that should actually, there's no randomization. It will always drop here and always come down here. Let's see if I made any mistakes. Okay, he's kind of rolling around. Not great. So what we're going to do is we're going to constrain the rotation as I mentioned a few seconds ago. You might like that effect of how it's spinning around for a different game, like, or maybe even this game, maybe you just want like garbage that's falling, some kind of debris. The physics is doing the work for you. So we go back to our prefab, and what we do is we freeze the rotation. Sometimes I'll edit out mistakes like that, but this is a good example of demonstrating why you use these. So you have that controllability over the rotation. Just like that, it works. And then what someone asked me in the comments how I'm going to control the out of bounds movement. I might just put a collider box underneath the entire map, and then if anything hits the collider box, it gets destroyed. But just like that, you've added a rudimentary pathing system. So you now have an enemy and there's a pathing system. Again, there's a couple of things we have to be mindful of. We eventually want it to not change this, which should be a simple if command. We just need a way to differentiate between which objects, so we may actually lean into tags like I mentioned in a couple of videos ago. Now what we do, so right now only a single object gets instantiated, and that's controlled by the game flow script because it says start. In the start section, which happens when the GM object gets instantiated, which is when the scene starts. So this only runs once. So what we need is this to happen over and over again. So what you can do, I believe the term is auto-recursive. You can have this look at itself. In other words, it waits 3 seconds, spawns the blob, and this says, okay, start all over again. So it points back to the beginning. And just making that one change, having the delay itself look at the delay. And there you go. Again, it's nice to see something really come together like that. Now really all of that remains as far as the pathing is to determine, is it going to fall right or is it going to fall left? And the other thing that we're going to do is make sure that it doesn't change the tile when it lands on it. So let's now go back to the scripts. And what we're going to do is right now we, on the blob conscript, simply say that when a collision occurs, do this. So what we want is we want there to be an if statement that looks at a random number and then says, okay, well, based on the random number, does it do this or does it fall in the opposite direction? So the opposite direction, we can just copy this and paste it. You're not going to want to run it like this. But the opposite direction was moving along, rather than the z-axis, it's moving along the x-axis, and it's a positive 1 along the x-axis. So again, we're emulating the movement of Qbert because it's a confined, as far as where you can move their fixed locations. Okay, so again, don't run it like this because it's not going to give you what you want. So what we can do is we can do a random number and a brief splice there. Sorry about that. Had some capture issues again. So this is crazy easy. So if random dot range, so that generates obviously a random range. Now you give the outer numbers, so 0, 2. So it's going to choose between 0 and 2, inclusive of 0, but not inclusive of 2. Not quite sure why Unity does that. So this number is inclusive, this one is not. I believe if it's searching for floats, then it is, but for integers, it's not. So that means you have two choices, 0 or 1, which is perfect because that's what we want. We're looking at it to fall left or fall right. So if it's equal to 0, and sorry, got to be a double equal sign. So if it's equal to 0, then we want the first one to happen. Else, we want the second one to happen. It is that crazy easy. Just hop them down here. So you can see the second one has already taken a different path. The collision caused the problem, but that's okay. We haven't done enemy collision detection yet, but you can see more and more the board is filling out, so that alone is proof that they are indeed taking different paths. See, he just fell this way and the other ones did not. So just like that, you've added an enemy that has variance to its pathing, and basically just about every dot has been hit, every tile has been hit now. So the only thing that's really left, I think, for this particular lesson is to have the enemies not change the tile. I'm not going to get into collision detection with Qbert yet. So how do we do that? Hey everyone, so in this video we are going to start tracking which objects are colliding with the tiles. So currently when the blob collides with a tile, it changes the color. We don't want that to happen, but we just had no control in place yet that checked to see which object was colliding. Also, we are now going to add a new enemy. This enemy's motion path will be similar to the blob, but when this enemy lands on a tile, it reverts the color. So basically the exact opposite of what the blob is doing unintentionally, it's going to intentionally do the opposite, and that is revert the color, because what he does is he's undoing what Qbert is doing. So he will actually be kind of a culmination of everything we've learned up to this point, because just like Qbert, he does have a direction he needs to face, unlike the blob. He is going to move like the blob, and he's going to reverse the color of the tile. So we're kind of bringing everything together. And the way we're going to do this, we're going to use tags, which I mentioned in a last video, maybe the one before that as well. So a tag is a way of determining what object is being identified. It gives you a way to identify an object, whether it's due to a collision or some other event. So what we're going to do, we're going to create 3 tags, one for Qbert, one for the blob, one for the nerd. If we ever add the snake, which will probably be one of the last videos I do for the series, the snake will also have its own tag. So what we're going to do, we're going to click on the blob, and actually at the moment it doesn't matter which one we click on. And up here we're going to click on tag and add tag. Just to clarify, choosing add tag does not actually add the tag to this object. It's actually creating a whole new tag. You then have to come back and select that tag. So list is empty. We're going to click on plus, and we'll do one for Qbert. Save. One for, we'll just call him nerd. Save. And one for blob. Save. And now what we do is we now have to go back into these objects. See how it's not tagged? Because you're really creating a new tag. And so the blob will be blob. Can't do the nerd yet because I need to create a game object out of him. Right now he's just an asset. But we can go to our Qbert object, and we'll probably eventually turn Qbert into a prefab as well. We'll see. We can decide that towards the end. So Qbert is going to be Qbert, and let's go ahead and just make the nerd. So let's click, drag him in. I already shrunk him. I mentioned how when I use when I use 3D Builder, my apologies, when I use 3D Builder, it makes the object enormous, so I just have to shrink it down. We also need to rotate him like we did with Qbert, so I believe, was that -90? Yes, and then 180 on Z. And so he will also get spawned, instantiated by the GM object and the game flow script. So we can just drag and put him in there. It's an original prefab. Delete him from the scene. We'll come back to him in a few minutes, and that gets us set to start checking what objects are colliding with what ones. And actually, there's one other object in addition to the snake that I will add. There is actually a green blob that is, if you click on it, if I recall correctly, it freezes all the enemies. So that will have its own tag as well, and that one actually has a benefit rather than a detriment. Okay. And a brief splice due to more technical issues. So let's work with the nerd a little bit longer. So let's go back to our prefab, and we're basically going to prepare the nerd just like we did the blob. So add component, physics, rigid body. We want gravity, so that's fine. I'm not going to freeze the rotation yet. If we need to, it's just easy enough to check that. Add component, physics, box collider. So this will take a little finagling just like the other times. And again, nothing really precise about this. The main thing is that the collider lines up with the feet, or else he'll be either floating over or passing through the tile. So we definitely need to make sure that's more accurate. But the other stuff is just general lining up. And like I said, I'm not too worried about the top of the object. We can always change that if necessary as far as making the collider box match it. But sometimes you want a little bit of forgiveness, particularly with a 3D environment like that where it's a little bit hard to see exactly what's overlapping. So you basically give the player the benefit of the doubt. Sorry, just trying to lower this and it's not cooperating. Okay, so now let's make the script that controls the nerd's movement. I have to open up this again because, like I said, had some technical difficulties. And what we're going to do is we're just going to copy this from the blobcon script and put it into the new nerdcon script. Could I technically use the same script for both enemies? Yes, but then I'm going to have to put in some if statements to check which enemy the script is attached to. So 6 one way, 1/2 dozen the other. I'd rather just do it this way because it makes a little bit more clear what's going on. So nerdcon. And not sure why it does that. It opens even though it didn't open that particular script. So similar outside of start, outside of update, we put in the collider. So basically, when the object the script is attached to collides with another object, and right now we're not checking, we're just presuming that it is the tile, random number is generated, and that will determine which direction it jumps down, either to the left or the right. So we go back to our nerd object, and we attach the script. So now should be basically in line with the blob. Like I said, the only thing is we froze the rotation. We'll see if we actually need to do that with the nerd. And yet another splice. So go to the nerd and go ahead and freeze the rotation. And I'm not quite sure why, but I actually had to tweak the collider box because when he dropped on the top tile, he wasn't moving. And to be honest, I'm not quite sure why. There shouldn't be anything up there preventing him from moving, but for some reason, I had to tweak this up and down a little bit. So not sure why, because again, the object, the 3D model itself isn't what's being used for collision, the box was, but for some reason, I had to tweak the box for the collision to work. Either that or it might just been a Unity moment. Any application can bug out, so I'm not sure if that's really what fixed it or if for some bizarre reason Unity was just bugging out just like any other application. So my apologies. I hope that doesn't cause any confusion. It's just I didn't want to see, didn't want you see me fumbling around. I'm not sure why that fixed it because it should not change what's being collided with up here. So anyways, let's now move this down. He lands and all is good. Now he bounced on me, so I'll just have to move him out of the way a little bit more. So far so good. As I mentioned, a couple things. One, we don't want him to progress the color. We want him to regress the color, which is fine because we haven't done that yet. And two, we're going to have to rotate him. But so far, so good. Now we're going to have, let's do the color changing. So, tiles. So this is when the tags are going to come into play now. So if other dot game object, make sure I selected the right one. Yep. Dot tag equals Qbert. And then this entire thing goes into squiggly brackets. So everything inside of the on collision enter is now subject to an if statement. So what's happening is the tile is now checking the tag of the object that's colliding with it. If it's Qbert, then this happens. So actually, let's run that to make sure that works, but it should. So what's going to happen now, Qbert will continue to change color. That nerd who comes down will not, nor will the other ones. There we go, there we go, there we go. He did not change any of those. And let's just make sure that the other blob does not change either. So it was that easy to fix it, just checking the tag. You're identifying what is colliding with the tile. And now we just build on that. So the next thing we're going to do is we're going to copy this whole thing. And now we're going to check to see if the collision is with nerd. Sorry, I've done a few takes. I just want to make sure I actually created the nerd tag. I had created it, but I had not attached it. The other ones were working though, so I think those should be fine. Yeah. So my apologies if this one's been a little haphazard. Like I said, I was having a few technical issues, which I'm not sure why, so it caused me to have to splice a few times, but I don't think anything is missing. You can see the entirety of the code on the screen for each script anyway, so if the tag of the game object that's colliding with the tile, if the tag is nerd, we want the color to actually be increased by 1. So color status plus equals 1. If color status is equal to 1, eventually that's going to have to be a variable because, like I said, sometimes the tiles have to be changed 2 or 3 times, but again, iterative. So if the color status is 1, then we don't want green color, we're going to want white. So just as we did this up here, public material white color. And now that that's there, white. Oh, it'd be nice if I could spell. Let's try that again. There we go. Okay, so if the tag of the object that's colliding with the tile is nerd, then color status, this variable is increased by 1, or the value of the variable is increased by 1. And then we check, well, if color status is equal to 1, then we need to revert it back to the white color. Like I said, this isn't perfect because once we have 2, 3, 4 different colors, we will have to check accordingly. And we don't want tiles to be increased. We want decreased by 1. We want tiles to be increased by 1. So that should be all the changes that need to be made. Excellent. And so if this works, this might be a good cut-off point. So let's change some tiles to make sure he has things to change. Oh, you know what I did? So I created the reference to the color. So need to select these white color. There we go. So I'm just selecting all the tiles and then putting white color for white color. But it did change, so we know it's right. It just couldn't find the material itself. So let's do this, and then this, and then this, and then this. We have plenty to change. There we go. So we're going to do this one more time. I'm just going to create a longer delay on the game, on his spawning, so I have more time to this, and then we do this, and then we do this, and then this, and this, and this. There we go. So he's not changing the ones that have not been changed yet, but he is changing ones that have been changed, and these are also not doing anything either. We already confirmed that before. So I think that's a good place to end. So we've added a new enemy. He has the correct pathing, and he has the ability to revert the color of a tile. Now, the other thing that we need to do, and I might do it in a separate video when we put in a bunch of the controls, and that is right now the tile really should have an upper limit as well. So I mentioned that we need to check not just for 1, but also 2 and 3 and 4 for when there's more colors, but also we don't want this to exceed 1 at the moment. So because what will happen is if another guy comes down and lands on it again, then color status will become 2, and then 3, and then 4 every time one clicks on it, and Qbert would have to jump on it repeatedly. We want this number to go no higher than the amount of color changes there are. But we can always do that in a separate video. So this video is primarily going to be a little bit of cleanup and tightening up the current control and the current coding. So we might add 1 or 2 new things at the end of the video because I do want to keep moving the tutorial forward. But this is really about looking at some of the gaps in the control and tightening everything up so as that you, if nothing else, you protect the player from themselves. That right now, as we've said, that if you hit a move button while you're in mid-jump, then you will jump again. And clearly that just breaks the game. So that's the first thing that we're going to fix. Now, what we're going to do, we're going to create a variable in the moveQ script because this is what's attached to our Qbert object. So this variable is going to use to track whether or not you are jumping. And the way we're going to determine you're jumping is a jump is going to be considered when you press one of the move buttons, and it ends when you collide with a tile. So public string, we're just going to store our letters Y and N for yes and no. So public string, and it's going to be mid-jump or whatever you want to call it, and it's going to default to no. So you at the beginning of the game, you are not in mid-jump. And now we're just going to check to see if you are in mid-jump. So you have to add another parenthesis here. Whoops, no asterisk, I'm so sorry. Just the parenthesis, because the entire set of conditions within the if statement have to be in parentheses, and each individual condition has to be in its own set of parentheses. And yes, it's supposed to be a double ampersand like that. And mid-jump equals N, and then a parenthesis at the end. And if you're using Visual Studio, when you have a parenthesis selected, it'll show you the matching one. So this shows me that the last parenthesis here matches the first parenthesis. So I should have the right amount of parentheses, but you can just keep moving inward. So like I said, each condition should be within its own set of parentheses. So you click on the next parenthesis, and you see it matches with this one, so on and so forth. So let's go ahead and just add this to all of them because, again, even though I like to run the code after each change, it's the same type of change. So I think we should be safe. Just remember to add that parenthesis at the beginning. So again, the logic that we've introduced is if this variable, that not just pressing the key down, you have to press the key down, and this variable has to be set to N in order to execute the jump. So right now there is nothing setting it to N, so setting it to Y, excuse me. So we are checking for this, but this condition doesn't change. This value doesn't change, so we need to make it change. So mid jump. Oops, there we go. and only one equal sign when you're setting it to a value. I think that's why you have to do two equal signs, is Unity thinks that you're trying to set the value when in fact you're trying to check the value. So if you're not jumping and this makes you jump, you should therefore be tracking that you're jumping. So now I'll just copy and paste that. For newcomers, like I said, the trickiest thing is probably getting the parentheses right. So again, each individual check has to be in its own set of parentheses. The entire if statement has to be a set of parentheses. And input is a little bit even more confusing because the key you're checking is also within a set of parentheses. So now the only thing that's missing here is we set this variable to the value y, but we don't ever set it back. So what we're going to do, we are going to check for a collision with the tile. At first, it's just going to check for a collision. We can later add a, right now tiles don't have a tag, so we can create a tag called tile, attach it to the tiles, and then if we really need to check whether or not a tile has been landed on, we can do that. But just about anything else you land on will already have code to handle, so it probably won't be necessary. But I do want to throw it out there just in case. Like I said, this entire video is about having tighter coding and control over what's going on. So outside of the update section, what we're going to do, we're going to do on collider and on collision enter. And again, we're going to replace this with the word other. Let's try that again. And now what we're going to do, we're now going to set the value back to n. So mid jump is equal to now. So makes sense, but here's the problem. Right now, the character has wobble. So there's a couple ways we can handle this, because I've already tested, and that if you're really laying on that key, you can still glitch it, because when he wobbles, he's landed, but he still needs that briefest of moment to not wobble. So we either have to fix the wobble, or we can just put a little code in place that gives a little bit of delay. That way, even though he wobbles, this still is not active yet. This is still saying that they're jumping. So what we're going to do is, rather than putting this here, we're going to go back to our good old friend IEnumerator. And it's going to be delay move parentheses. Again, don't let the underline mess you up. It really shouldn't do that, because it's just telling you that there's nothing in here. Yield, return, new, wait 4 seconds, and you can do a decimal. Let's do just like, let's try a 1/10 of a second. And since it's a decimal, you need to put the letter F there. This is a float. And then we'll take this, cut, paste. Whoops, I actually didn't hit copy, and so I copied a blank. So that's just mid jump equals n. So yes, I could have done this originally, but I kind of wanted to walk through the logic of why I was doing this. And now this, when the collision occurs, will instead refer to this. So start coroutine, and it's delay move, also with parentheses. That should do it. We'll see if that's enough. The problem with taking this approach is it creates a sense of lag. that, hey, I hit the button and nothing happened. So that's the only thing that we have to be careful of. This is kind of a band-aid. Fixing the wobble is a better solution. So we can certainly look at that in another video, but first and foremost, we need to lock down player control. So if I haven't forgotten anything, this should now take care of that. So it will definitely take care of, you can know if you rapid click on jump buttons when you're mid jump, that is definitely taken care of. The second part, the delay, is again to try to prevent him falling over because he wobbles a little bit. So rapid fire hitting A is not a problem, or any of the keys. I just hit it a bunch of times, was not a problem. Do it again. Not a problem. Now what I'm going to do is I'm going to keep rapid firing even when he's landing to see if that 1/10 of a second delay is enough. Looks like that 1/10 of a second delay was quite enough. Because like I said, I was testing this before and I was pretty consistently knocking the little fella over. So the question is, how snappy will the control feel, and do you really need... Oh, that was interesting. Oh, I know why that didn't get changed. Sorry. As an aside, I'm pointing with my finger. I'm so sorry. Let's try with using the mouse. The reason why this didn't change is because Nerd landed on it, and he increased the number by 1, and we already said that there's no cap, so that's one of the other things we're going to fix in this. But, so, mission accomplished for this first part. Rapid firing no longer creates a problem, and it's adjusted for that little bit of wobble. So again, couple things, we can try to find out what the cause of the wobble is. It might be just the size of the collider box. Maybe its base needs to be a little bit wider. So don't make it any taller, but make the base wider. Maybe that will help. But anyways, so what we're going to do, we're now going to... one more thought. So this might be a little bit excessive. 0.05 might do it. So you're going to have to do a little testing, because, I mean, I was really laying on that key to see if I could make him fall over, and it didn't. So it's possible you could make this even less, because it's basically how long does he wobble. And it's the briefest, you can barely even see it. So this actually might be a satisfactory solution, dropping it down to 0.05, whatever. But anyways, the main issue with player control has now been resolved. You can no longer double, triple, quadruple jump and break the game. You can now only jump once you've landed. Okay, so that was the first thing. The next thing is what we just observed, and that is we need to control the value for the tiles, and that's pretty easy. So right now we have constants. We'll keep using constants. We'll eventually change these to variables. So what we're going to do is, so this is looking for a collision with Qbert. If Qbert collides with it, then this gets decreased. So what we want to do, we don't want this number to go beyond 0. We don't want to go below 0. So what we'll do is we're going to actually put an adjustment here. The reason for it is if we increase this back to 0, then this executes and we'll mess this up because it'll keep minusing out 1. So we don't want this to keep executing. So in other words, what happens is this should only happen once. If he jumps in on again, it'll get set to -1. This won't execute, but then we adjust it back to 0. So if color status equals, actually let's just do less. If it's less than 0, then color stat, try that again. Color status equals 0. So again, sequence matters. We're adjusting the number back to 0. That way this doesn't get executed. So it's okay for it to briefly dip below 0. We just need to adjust it back to 0. And similarly for this, what we're going to do for nerd, it's also going to be within the tag check. If that has been increased, what we're going to do is if status is greater than 1, then we bring it back down to 1. And that alone should actually fix the remaining tile issues if I've thought this out correctly. Okay, so let's run it. Actually, let's see how much of a delay we have for nerd. Actually not. We want game flow. So let's bump that up to like 15 seconds, and we'll bump this up a little bit more so it doesn't land on my head. So that gives me a couple more seconds to hop around, because I want to be able to repeatedly jump on all right. Yep, so they're changing. Now, he's landed on this one and this one. So if the code works, I should now be able to hop on these and they will change. So we're going to go up 1 and then down 1. And it did change. So just like that, we fixed the issue with the tiles, because I repeatedly jumped on the tiles and yet he was still able to change it. And the tiles that he landed on that I had yet to change, I was able to change. So I know that it's not going outside of the range that it's supposed to. So the third thing that needs to be done is we need nerd to rotate properly based on the direction that he's heading. So to do that, what we need to do, we need to go to nerd. So when he moves, he needs to rotate in the corresponding direction. So we just want to grab the corresponding lines from Qbert. So when it's 0, 4, -1, 0, 4, -1, it's this. Yes, I could have thought it out, but why reinvent the wheel? We already have the coding there, so. And then when it is 140, 140, it's this. And now, since I'm testing him, as opposed to testing nerd instead of testing the tiles, we actually want him to spawn a little bit quicker so we don't have to wait. So game flow, and we'll drop this down to like 4 seconds. Yep, he's facing the right direction. So just like that, it was fixed. So now that we've done that cleanup, I think what we'll just do is we will add a giant collider box under the board, and that way it will catch any object that goes off the board and then destroy it, because unless you destroy an object, it's still taking up memory. So what we're going to do, and there's actually a few ways to do this. You could check the vertical position, and if it goes beyond a vertical position, you could delete it. really doesn't matter in a game this simple. So let's do game object, create empty, and we are going to add a component. We're going to do physics, and we're going to do a box collider. And this one needs to be, let's see, like 15 by 15. And let's actually rotate from above so we can position this correctly. I believe that should be plenty. I can't see how he could possibly hop beyond that. Yeah. Probably a little bit bigger than it absolutely is necessary, but that's fine. Just move it up a little bit. Collider boxes can do some weird things when objects are moving really fast that the collision isn't detected. So I want this to be fairly close to him jumping off the bottom. So what we'll do is we'll give this, let's call this safety net. And let's give it a tag. So add tag, we'll call it net. Go back, net. And now what we'll do for Q, now we have an on collision enter. But what we're going to do to differentiate them, the safety net will be set as a trigger. So this won't work for a collision, for a trigger. It only works for an object that's not a trigger. So what we do is we do on trigger. Let's try that again. On trigger, why is this not doing on trigger? Don't know. So on trigger enter. And what we'll do here, we will say if, so again, we're just going to check the tag, if other dot, and here you don't have to do game object, you can just do tag. I'm not sure why collision requires you to check, to declare a game object, and this you can just say tag. So if other dot tag equals net, then we want Q to be moved back to the top. You're also going to subtract lives, but I'd rather have the lives system be its own thing, but this is starting to brush up against it. So get component, transform. Oh, sorry. Not parenthesis. Losing my mind. Transform dot position equals, again, 3 coordinates, 3 vectors. And I believe we said it's 0, 0, 0 for the top tile, but we want them to appear above the top tile. So we will do, let's do +1, 0. Now, since objects do drop onto the top tile, that could potentially create a collision up there. So we might want to do something like, well, could make him like invincible for a brief moment. So even if he collides with something, it doesn't damage him at first. But there's other ways. There's certainly ways we can handle the his spawning at the top. So this should move him to that. He'll, I believe, keeps his velocity. We can fix that if necessary, but let's see what happens. Actually, let's just fix the velocity to begin with. So get component, and its rigid body, and its velocity equals new vector (0, 0, 0). However, even though we're setting the velocity to 0, 0, 0, because it's in mid-air, gravity will take it, and that's what we want. So we want to offset any kind of diagonal that's going on, and then gravity will take over. So that should take care of it. And actually, I can jump off just about any. I could really jump off any tile, and this would work. But we'll just, yeah, let's just jump right off the top here. So there we go. Jump off this one. Almost want it to be a little bit lower because we'll eventually fix that. Obviously, that's because we haven't done any enemy control yet. So let's jump off the front since we've jumped off the back in a few places. Yeah, I think it happens a little bit too soon. I was concerned about him falling really fast and messing things up, but I think he falls a little bit too soon because you can still see him. You kind of want him to disappear off the screen. Okay. Okay, so in this video we are going to do two things. One, we're going to look at how to handle collisions with lethal enemies, and the reason why I say that is because if you collide with the nerd, if you intercept the nerd, you don't lose a life, he gets destroyed and you get a bonus. So we're going to be looking at the moment collisions with the blob, but it'll be just as easy to extend that functionality out to the snake and the other enemies that populate the game. So we're going to look at collisions with the blob, and we're going to create a live system so that when you collide with the blob, you lose a life. We already created the safety net, so when Qbert collides with this collider box, he already gets reset to the top. We just need to also have that reduce a life. So let's start with that because that'll be the easiest one to build on and to test. So the way a live system works is really just creating a variable. So we're going to go to our gameflow script, and it's going to be a public static int. So we'll use integers, and we'll use remaining lives, and we'll set it to 3. And just to clarify, calling this remaining lives in and of itself does nothing. That's internal documentation. That's to let you, the designer, know what you're going to use this variable for. The only way this actually works like lives is if you make decisions based on this value. So remaining lives equals 0. Now you're going to load the game over scene, that kind of thing. Okay, so gameflow, we added a static int, and we set it to 3. 3 tends to be the default number starting amount of lives in a lot of the classic arcade games. And now we just go over to move Q, and we already have a check for collision. So, or should I say collision with the safety net. So what we have to do is we just have to reduce that variable by 1, and then in the debug log, we'll have it display so we know that it's working. So Again, since it's a static variable, we have to declare where it is, or we have to rather say where it's declared. So game flow is a script where it was created. Remaining lives minus equals 1. So that should look familiar. We're saying take the current value, so what it's equal to, and minus 1 from it. And now we're just going to do debug.log and have that value displayed in the debug log so that we can make sure it really worked. So again, we have to say where that variable is, gameflow.remaining lives. Semicolon at the end. Okay, so just like that, we have the beginning of a live system. Now, no decisions are going to be made yet. We'll probably do that at the end of the video. And so let's run it. So the debug log shows up down here. So if I jump off, in fact, I can just jump off right here if I really want to. There you go, 2. And we'll just kind of jump around, not that it really matters. And he stopped because he collided with Qbert. And we'll hop off here. 1. 0. And then at that point, you would simply have a command that's, and we'll do it, like I said, at the end of the video. It'll say, if remaining lives equals 0, then load such and such scene, the game over scene. We'll probably create the game over scene at the end. It'll be something very basic, just as a placeholder that this is where you display, say, the high scores and things like that. Now what we need to do, we are going to check for a collision with the blob. The blob is a solid, so that means that in the Qbert script, it would be detected here on collision. So right now we're not checking for what's being collided with. So the first thing we have to do is we have to say that this should only happen if you're colliding with a tile. So what we're going to do, we will create a new tag for the tile and apply it to all the tiles. So what we do, doesn't matter which one you click on because we're just going to create the tag first. So add tag, plus sign, and we'll call it tile. Save. And now we select all of them and add the tag tile. And no, you're not imagining it. I did move Qbert in between tutorials. I got tired of selecting the top and then the bottom and skipping him in the middle. The order in here, for the most part, does not matter. It only matters if you're within, say, like a UI layer. And then, yes, the order in which things are displayed matter. But since this is a 3D environment, whereas the UI is 2D, this is a 3D environment, so its order, for the most part, doesn't matter. So now all the tiles have the tag tile. So what we do, we come back here, and again, this is the move Q script, and now we add a condition. We say if other dot game object dot tag equals tile. So only if this is equal to tile. So this always happened when there was a solid collision. Now we're saying only do this if it's a tile. If it collides with something else, we can now have a decision based upon that. So since we said a collision with just one lethal enemy will make all the enemies on the board disappear, basically it gives Qbert a brief respite. What we're going to do, we're going to create another static variable that will indicate that a life has been lost. So we go back to game flow. We go back to public static, and we'll use a string. And this will be, we'll call it reset board. You could do life loss, reset board, whatever. And we'll default it to no, that at the default value is the board is not being reset. I don't recall if I mentioned it in the other video, but someone asked me, or they really stated, they said, don't use a string for yes or no, use a Boolean. the reason why I don't use Boolean, and technically they're right, but the reason why I don't use Boolean is too many times I think that it only needs two conditions, yes or no, and then it turns out I need like a third condition. And so if you're using Booleans, you can't do that. You have to go back and you have to basically uproot the code and change it. Whereas with the string, you can just check for a third value or a fourth value. So I don't recall if I mentioned that in the last video, but that's why I use strings instead of Booleans. You absolutely can use Booleans, but like I said, just my experience, too many times it turns out I needed a third condition, and then you kind of have to uproot the code for the Boolean. So, public static string reset board, no. So what we're going to do, we're going to have put into the script a check to see if this is yes, and if so, then the object the script is attached to will be destroyed, such as the blob, such as the snake, okay? So let's go to blobcon, and this will just be in the update section. You don't need all the spaces. I'm just being weird. So if, and we want to do it in the update section again because we wanted to check with every frame. If gameflow dot reset board equals y, then we want something to happen. Oh, sorry, 2 equals. I'm probably going to do that like until I stop using Unity. So if reset board is equal to yes, then we want something to happen. Well, we want this object to self-destruct. So destroy game object. Now, eventually, you may want to put in a timer because in the game, the board freezes for like 5 seconds, so you have a chance to process, oh yeah, I hit it, enemy hit me, whatever, and then he gets reset. But for the moment, we'll just have it destroyed right away because, like I said, you can iterate on this. So again, the script is attached to the blob. If reset board gets set to yes, then the game object will be destroyed, whatever game object the script is attached to. So we now need this to actually happen. So I think if you jump off the board doesn't reset, actually. I'd have to check. It's not a big deal, but we'll definitely have the board reset for collision with a blob. So we go back to move Q. And as I said, in here, we can now check to see if a collision with a blob happened. So if, other dot game object dot tag, if it's equal to blob, then we want something to happen. We want that variable to change. So gameflow dot reset board equals y for yes, obviously. So if we collide with the blob, we want the board to get reset, and we want the remaining lives to be reduced. So gameflow dot remaining lives minus equals 1. So we collide with the blob, the board gets reset, which causes the blobs and everything else to self-destruct. The remaining lives will be reduced by 1. And we want you to get moved to the top of the screen. Again, eventually we can put in a delay. So for now, we'll just move them, and we already know how to move them because this happens, the trigger with the net. So we can just borrow that. And we can just bring that down here. So he gets repositioned, his velocity gets increased. His velocity gets reset. My apologies. His velocity gets reset, and then gravity takes over and will bring him to the tile. So the last thing we want is we now want to have this get reset, but we want to make sure that that any object gets deleted has enough time to delete. So we'll create another routine with a delay, but it'll be a very slight delay. And we will do IEnumerator, and it will be delay reset. So in the reset, we're going to do, again, you start with yield, return, new, wait 4 seconds, and it doesn't have to be long, like 0.1, so a tenth of a second should be plenty for every object to get a chance to cycle through. And like I said, you could actually build this out, move this down here, so that's the delay, but this is good enough for now. So, collision the blob, reset board gets set to Y, which then will trigger the blobs to self-destroy. The remaining lives gets reduced by 1. Notice we're not making a decision based on that yet. He gets repositioned, and now we need to reset that value for the reset board. So gameflow dot reset board equals n. And then we need to actually call this. So start coroutine, and it's delay reset, also with its parentheses. So we're actually really close to being done with this lesson already. Like I said, we will probably the end of the video, we'll start making decisions based on remaining lives. So now what we need to do is to make sure there's enough blobs on the screen so it's easy to check this. Now, one thing we may have to adjust for, blobs are solid and Qbert is solid. So when they collide, it may knock him about, so we might have to do something to steady him. So we might have to reset his rotation here, actually. Which is easy. We already demonstrated that in the first or second video using Euler angles. But you'll see. So let's run it. Actually, let's go to GameFlow, and actually this isn't saved. We can see there's an asterisk there. So that wouldn't have worked. And then we need this to spawn a lot faster. Let's have this spawn like every 3 seconds, just so there's a whole bunch. And then we run it. Come on, blob, don't let me down. They keep going that way. There we go. So he did kind of wobble, but he did indeed reset to the top. The blob got destroyed. And if you want, well, we could put the debug log here, but I'm sorry, not there, not for spawn, my apologies. We could do the debug log here, but that's just troubleshooting. So we already looked at it being subtracted. So he did wobble a bit. There's a few things you can do that to possibly alleviate that. But what I think we'll do, we'll leave it for now. We can leave that as a bug fix at the end. So, but again, it happens because they're solid objects and they're colliding. You can try changing like the weight of the objects. So, like if you go into any object that has a rigid body, you affect its mass. So you can make this like a really low mass and make Qbert a really high mass. And that might help resolve the wobble, but it's working at the moment. Okay, so what we're going to do, we are now going to create a brand new scene, which we hadn't done up to this point, and it's going to be the game over scene. And basically all it's going to do is say game over. It's just to put that kind of placeholder so that you have some code to address it. So let's save our work. So File, Save, and then New Scene. And we'll immediately save this, and we're going to call it Game Over. And again, this is really just a placeholder scene, so we have something for the code to refer to. So let's see where our camera is. Our camera's there. And I'm not going to do anything fancy with this. Technically, since it's a 3D game and you want this to be 2D text, you could use a UI. That's really a tutorial in itself. I'm just going to use a text. So I'm just going to go to 3D Objects and go to 3D Text, and we'll write over here in the inspector for the text value of the text mess component. We'll just do Game Over. And if we click on our camera, we can see a preview, and it's completely and utterly wrong. How's that? That's better. And then what we can do, we can actually just increase that size. So make the font like not too worried about it being blurry. There's things you can do to clean that up, like you could use a lower character size, I believe will make it a little bit cleaner, but then you have to bump up the font. And again, this is really just meant to be placeholder, so you have something for the code to refer to. There we go. So what we need to do, like I showed you in the other video, we need to add it to the build. So File, Build Settings, Game Over. And then what we need to do, we need to put into the code that we want that to get loaded when remaining lives equals 0. So was that in game flow that we did? Yes, this is where we did the low level. So we already have scene management up here. So I guess what we can do is, just as we check in the update section, so if remaining lives is less than 1, that way if for some bizarre reason it goes from 1 to -1, I can't think of any reason why, this will still catch it. Because 0 is less than 1, so if it goes to 0 like it should, this will work. But if for some reason it glitches and goes beyond 0, beneath 0, below 0, this will still catch it. And then it's just same coding. So scene manager dot load scene, and then it was game over. I think that should do it. Now we need to save this. We go back to, when you build it, it will run in the order displayed here. But when you're testing it, it'll start on whatever level you currently have loaded, whatever scene you have currently loaded, unless you have like code in place to say load a different scene. So we'll come back to here. And that's one of the annoying things, is that like the director's camera, whatever you want to call it, it stays the same across scenes. So what works in one scene puts you kind of out of place in the next scene. But only from the director's point of view, the player camera is fine. So let's just kind of hop off the board. Hop off the board again. Yep. I believe what happens, I got hit a bunch of times. It's hard to tell because things kind of piled on me. See, that's the solid collision that I was talking about with him. So that's one of the things we'll fix. But for now, what we'll do is we will just delay him since we're only trying to test. So game flow, I'm just going to have him not spawn on a regular basis, and we can actually make this take a little bit longer too. So I just want to like hop off the board. There we go, and we'll hop off again, and we'll hop off again, and there we go. So that when you can see it says 0, and we did indeed go to the game over scene. So I think that should be it for this video. That's really everything that I wanted to cover. So we looked at how to handle collision with the lethal blob, and that coding will work for the snake. It'll work for the other guys. It's just a matter of checking for creating a tag, affixing the tag to the object, and then you just check for it. So what you could do is here, you could just do object.game, other.gameObject.tag equals blob, or other.gameObject.tab equals snake, or, you can just, you don't have to rewrite this whole thing. You can just put some ors in here. And again, I'm just kind of thinking ahead. I'll show you how to do that when we add the additional enemies. But I think that should do it. I have no reason to believe that it won't work for the blobs. Don't want to waste your time because that's going to be a bunch of hopping around, but it should work. And I think that should do it for this video. So that's basically what we wanted. We have a game over scene now, and you can just build that out. And like I said, in a later video, we'll look at that. I'm just trying to put all the core functionality in place. Okay, so in this video, we are going to look at adding scoring. So there'll be a couple elements to this. One, landing on a tile and changing the color will increase your score. Landing on the same tile again will not increase your score because you haven't accomplished anything else into the later levels where you do have to hop on a tile multiple times. And completing the level will also give you a bonus. And then we'll look at landing on the non-lethal enemy nerd here. Hitting him should give you some kind of bonus, and so that will be the last scoring that we'll add. And at that point, you can just build on that. If you add more enemies, you'll see how to handle the scoring. If you also notice there's a few sound files, probably won't get to that in this video. They're not utilized. They were just put into the asset area. We'll probably do that in the next video. And just to call them out, it's called Retro Sound Pack, and I believe the publisher was Mululu. So to give credit where credit is due, and you'll see that probably in the next video. So this one is just going to handle the scoring. Okay, so like a lot of other values, it's really simple how you track it. You have to create a variable. So in our GameFlow script, we're going to create public static int, and we'll call this total score. Actually, let's set that to 0 to begin with. And what we'll do is by the end of the video, we'll add a text object or text object on the scene, and that text object will be set to this value, so it will display that score. But we'll get to that in the end once we make sure the scoring is working. So we've created our variable. It's a static variable, so it's accessible throughout the entire application. Now, if we go to our tile script, this is where we're already checking to see if Qbert has landed on a block. Specifically, in this section is where we check to see if color status has just changed to 0. If it does, if it has just changed to 0, then this is where we want the score to be added, because this is where the color is being changed, remaining tiles are being reduced, and so this is where we want the score to be increased. So GameFlow dot total score. In this case, it's plus equals, and we'll give them 100 points. So just as this is taking the current value and subtracting something from it, this is taking the current value and adding something to it. So one obviously is subtraction, the other one is addition. We're adding 100 points whenever this condition is met. Now, what else we're going to do, we want there to, let's display this too, because we don't have the text object yet. So let's do debug.log, and we need to declare or state where it's declared game flow, and it's total score. Save that. And then, so we said 100 points per tile, so times 28 tiles, that's 2,000 points. But we also want to give people a bonus for completing a board. So we're going to go back to game flow, because that is where we check to see if the board has been completed. So remaining tiles equals 0, start coroutine. So that's this one, load next level. So this is where we say wait, because usually there's some kind of pause where you see like a tally or whatever, or the screen flashes color. Remaining tiles are reset, and so this is where we'd get the bonus. So total score plus equals 500, 5,000, whatever, doesn't matter. Now, just to be clear, the reason why I didn't say game flow is because I'm in game flow. So if you're not in game flow, you do have to say where this is located. But when you're in game, so if you're not in game flow, you have to see where it's located. If you're in game flow, then you don't. The system is smart enough to know that that's where the variable is declared. Okay, and let's also do debug.log and total score. So if I did not forget anything, then you should only get 100 points the first time you land on a tile and not again. You should get 500 points, and then the board should reset, and then you should have 3,300 to begin with. So let's now run this. And I've been testing quite a bit, so I increased the delay for the spawning of the enemies. And I wasn't pointing it out, but down here you can see that indeed it is 2,700, 2,800, 3,300. And let's see if it keeps counting. It sure does. So everything was indeed properly reset. Great. So just like that, we've added scoring. Well, we've added scoring for landing on blocks and changing them, and score for completing the level. I do want to do one more. I want to do scoring for when you land on a non-lethal enemy, ones that you're supposed to catch. So for this one, we mentioned that there's an issue with collision because both objects are solid. And I said there's a few ways you can handle this. You can try increasing the mass. So Qbert has a lot more mass than the nerd. Reduce the mass of the nerd, increase the mass of Qbert. And again, you do that within the rigid body component. But what I'm going to do is I'm going to add a second collider to the nerd, and it's going to be a trigger collider instead of a solid collider. So by doing that, by adding a trigger collider and have the trigger be larger and totally encompassing the solid collider, the trigger will occur first. The reason why this is important is a trigger does not create a solid impact. So if you want to think of a trigger collider as maybe to checking that you've entered a zone or something that doesn't impede you, like you're in an area of gas or temperature or something like that. So you want to know that someone is in a certain area, but there should be no physical impediment. So you can use a trigger to check that you've entered in that area, but it doesn't actually impact velocity. So we're going to put a trigger collider surrounding the nerd, and it has to be larger than the current box collider. That should not cause any problems because the only script that checks for a trigger is Qbert. So the tile doesn't check for a trigger, neither do the other objects. So adding a trigger collider should not cause any functional problems. So we're going to click on Nerd. We're going to open Prefab. We're going to add component. We're going to do Physics, Box Collider, and we're just going to kind of sculpt this so it's bigger. And I will eventually change the perspective so I'm looking down. But the important thing is, as you can see, that solid collider has to be inside and totally encompassed by the trigger. That way the trigger occurs and there's time to process a change without the solid collision knocking anyone off course. This is actually also very useful in other scenarios too, where maybe you want to check that you're close to something. Like if this is way out here, you could check that you're close to something without actually hitting it. So maybe once you get within a certain proximity, you want it to move, that kind of thing. So there's a lot of legitimate reasons why you would do this, why you'd have a larger trigger. Okay. So we have our trigger. Now, like I said, we'll just take a quick look. So again, on collision, ignores triggers. It specifically has to be on trigger entry. So move Q, which is attached to Qbert, he checks for a trigger collider, but only on net. So Qbert will currently ignore that trigger collider. The tile objects only check for collision. They do not check for triggers, so they will ignore it. Game flow doesn't get collided with at all. Blobs only check for collisions. So basically everything is going to ignore that trigger object. And again, since the trigger component, since the trigger component again is not solid, it shouldn't create any kind of impact issues. And that's the very reason why we're doing this. So for the nerd script, outside of start, outside of update, outside of collision, but inside the public class, we're going to add on trigger enter. And again, that auto populates if you're using Visual Studio. So now what we're going to say is if other.tag, and again, if it's a trigger, you don't have to say other.gameObject, you just do other.tag. Again, I don't know why, but just roll with the punches and know that that's the way it works. So if the tag of the object that is colliding with the trigger component, if it's Qbert, if the tag is Qbert, then we want something to happen. Well, let's give you, say, 5,000 points. So we have to say where that score variable is, game flow, not game object. Wow, I am just falling apart here. Okay, game flow dot total score plus equals, and there's going to be a lot of things going on the screen, so let's do like a solid 5,000. So that way we can easily see that that's what you got the score for. So 5,000 points and then destroy game object. And order does matter. I am just totally falling apart. My apologies for any confusion. Destroy game object. Okay, so again, the trigger script is attached to nerd. It's looking to see if a collision with Qbert is occurring to the trigger object. If so, increase the score and then destroy the object the script is attached to. The script is attached to all the nerds, but it's only destroying the nerd you are colliding with. I think that should do it. We might still have some weird things happen if he lands at the top here and Nerd lands on him at the same time, and there might be like a mid-collision here. But again, like I said, there's things that we can do to avoid those kind of collisions, so don't worry too much about the bugs like that. And actually, let's also debug.log. And we're going to gameflow dot total score. And sorry, jumping all over the place. How often is he being spawned? So he gets spawned after 4 seconds, and then will be spawned every 4 seconds. So there should be a bunch of them on the screen. And I'm going to keep Qbert moving because, like I said, part of what we're trying to do is seeing if there's any kind of collision issues. Actually, it looks like... Did I not make it a trigger? I didn't. So here am I sitting saying it's a trigger, it's a trigger, a trigger. I didn't even make it a trigger. I'll leave that mistake in. It's a good teachable moment because now you'll see that it won't have an issue. See? It's ignoring the trigger. So, no problem. No collision issue. Because again, it's hitting the trigger, so it's not wobbling. Now, if I left them up here, depending on spawning, it could potentially create an issue. And we can see our score down here. It's going up by 5,000. Okay, so I think that's a really good place to end this video. Hey everyone, so in this video we are going to look at adding sound. I had mentioned talking about possibly continuing with the scoring, but that's really a UI function at that point. We added the scoring functionality, and that the displaying of the score is really a UI function, so we'll kind of wrap that up more towards the end. In this one, we're going to add sound. Now, for a sound to play, you basically need two different things. You need an audio source component, which we'll get into a second, but when you click on an object, we said that there are different components. Well, there's one called an audio source. And then the second thing you have to do, you have to create references, just as we created references to these other objects, you have to create references to audio clips, and that the audio source can play different audio clips. So I just wanted to give you a little bit heads up about that because the functionality is a little bit odd, that it's not just you've got this component and you're good to go. If you want to play multiple sounds, you really have to understand the difference between a source and a clip. So let's get into it. What we're going to do, first we're going to select our tiles and we're going to add the audio source. So add component, audio, audio source, and we get rid of play and awake because if you leave play and awake, it does just that. As soon as the object is instantiated, it plays. So as soon as the board appears, every single tile would play. We don't want that to happen. So that gives us our audio source for the tiles. Now you could say, well, wait a minute, why aren't you adding the audio to Qbert? Qbert's making the change, isn't he? From a gameplay point of view, that's what the player would see. But don't forget, from a coding point of view, it's not Qbert that's changing the color of the tile. It's actually the tile itself. The tile is detecting a collision with Qbert, and the tile is making the change. So what we're going to do is we're just going to put the playing of the audio clips right in here. So we already check for when the tile should change color, and we'll put the audio clip there. The second thing that we're going to do, we're going to have a separate sound for when the tile does not change. So we'll have one sound from one sound when the tile does change, one sound when the tile does not change. And I might have pointed it out in the last video. If not, you can see there's a few audio files here. All I did was go to the asset store and I downloaded Retro Sound Pack, and I believe the publisher is Mululu, to give credit where credit is due. They're the ones who made the sounds. Anyways, so we have attached an audio source component to the tiles. Now we need those tiles to be able to play the sounds. So what we do, we go to the tile script and we're going to make a reference to that audio source. So public audio source. And we'll call this tile sounds. And as I mentioned, I like to append a few letters to the end of certain references so I know what type of object this is. So we'll be using SNDS because that's an audio source, and then SND for the individual clips. So public audio clip, and we'll call this change color SND. Public audio clip, no color change SND. And then if you need more and more sounds, you can just keep putting them here. Like maybe you want a separate sound for when nerd reverts the color. But once you see 2 or 3 of these, it's just rinse and repeat at that point. Okay, so let's go back to our objects. Okay, so what we need to do, we need the tile sounds is looking for an audio source. So what we need to do is we need to drag the audio source to there. Selecting all of them may not create the option, it might not create the effect we want to. You can try it. I'm just going to play it safe. I'm going to drag the individual audio sources to the individual references on them. So it'll take a few extra seconds, but I just want to make sure that we get the effect that we want. So again, this is just making a reference to the component. It might seem redundant. Sometimes Unity is like that, where it seems like you have to do something kind of redundant to make it work, but and as I mentioned at the very first video, you could actually do, a couple hours making just one tile and do everything to it. Give it its colliders, give it its code, give it its sounds, its color changes, and then you make the board. And from a design point of view, that would be very efficient. But from a teaching point of view, I think that would be very challenging for people to see, literally a couple hours trying to explain why you're doing all these things to this one tile. So it creates a little bit more busy work at the end, but I think it keeps people interested seeing the game fold out and develop much quicker. It's not like it takes up that much time. It's only 28 tiles. And it does matter if each object has its own sounds, because now in this particular example, it doesn't really, because they're all going to play the same sounds. But think about a game where maybe you have different types of surfaces. You have grass, you have rock, you have metal, wood, okay? So when your character walks over it, or if something drops on it, depending on the type of surface, it should make a different sound. So in this case, you could call it, say, sound 1 and sound 2 or whatever, a collision sound, and then each one would get the appropriate corresponding sound. So if it's wood, it would be some kind of wood clatter, metal clanging, that kind of thing. If nothing else, seeing this, it reminds you that this step needs to be done because I think that this is an easy step to forget because, again, it seems redundant. It's like we have an audio source component. Why do we have to make a reference to it? But that's the way it works. Like I said, the main thing I was concerned about, I didn't want one object trying to refer out to another object's audio source. So that was the main concern I had. But again, if you want to try it, that's fine. So now what we need to do, we now need to assign the audio clips. Now that we can do as a group because the clips are coming from down here. So we're going to select them all. And we said tile change will be for change sound, and no tile change will be for no change sound. Okay. Back to our script. So now those have been populated. So now what we need to do, we already have this section which checks for whether or not the color should be changing. We just have to make the right sound clip, the right audio clip, be associated with the audio source. And a brief splice there. I needed to change the settings on my video and audio capture. I normally don't capture system audio. That way I can listen to music in the background and it doesn't get recorded. But obviously, if I need to demonstrate the sounds are working, then I do need to capture system audio. So if my voice sounds any different, any fainter, that's why. Okay, so we said that in the tile conscript, this is where we're detecting whether or not a tile needs to change color. This is where we say the tile does need to change color, and therefore this is where we need to change the sound. So first we have to refer back to our audio source, which is tile sounds. And then we're saying that we're going to change the clip that's associated with that sound, with that source, excuse me. And then that is one of these. So here we said that we want it to be change color sound. And then we just play it. Oops. And then what we can do is, for now, we can just do an else that says, okay, if it's not equal to 0, actually, we can do less than 0 for now. We might, let's just do an else. I don't want to make this too complicated because at the moment I just want to focus on the playing and the sound. So here's the thing. Right now this is saying if this is not 0, then go ahead and play the sound of it not changing. However, like I said, in later versions of Qbert, when you get to higher levels, okay, you need to change multiple times. So this will eventually have to check only for when it's gone below 0. And then it's very similar. Again, like I say, rinse and repeat. This time we said it was no color change sound. So no color change sound and play. So again, you're assigning a sound, excuse me, a clip. I want to make sure I'm using the correct terminology. You're assigning an audio clip to the audio source because this is the audio source. Okay. So we're saying assign this sound, this clip under these conditions, and then play it. Under these other conditions, assign this. And again, this is only happening if Qbert has collided. So it's completely ignoring these sounds won't play if it's any other character. So like I said, you can build on this so it checks to see if nerd is landing on it and then changing that. Actually, my apologies, we already did that. We already had nerd be checking to see if nerd landed. So what we do is in this section, you could play the other sound of it like reverting. Okay, so I think if I haven't forgotten anything, that should do it. We assigned the audio source to all the objects. We assigned the clips, and then we change the clip based on whether or not the color needs to change. I think that should just about do it. And actually what I'm going to do, just to keep things from being confusing, I am going to reduce the spawn of the nerd and the blob. It doesn't matter what number, I'm just trying to make it a large number. And the reason why we heard that the non-change beep is you have to remember he lands at the beginning. So like I said, one of the last things you can do is put in some controls that very specifically address the first landing, that kind of thing. So like you could put like a slight delay so as that no sounds play for like half a second after the board has instantiated or something like that. There's controls you can put in place. Like I said, the last video or the last couple videos of this series will basically be any outstanding requests. So anything that gets requested that I haven't added, but at this point, basically everything is in place that needs to be. So as far as sound, so if he lands on a tile that needs to be changed, the color one sound plays. If it doesn't need to be changed, a different sound plays. And what we could now do, we could also do a sound for him falling off. That's a little bit more challenging because the collision is down here, and usually as soon as he jumps off the board is when the sound plays. So there's a few things you can do. You can add like another collider. So like if we rotate around here, we could add another collider under the board here to check for when he's falling. But if you want, just so you understand how it works, we can just have the sound effect play when he lands on the safety net object. And sorry, another quick splice there. So what we'll do, we click on Qbert, and what we'll do is we'll add an audio source to him. We will use the fall sound file, in this case an audio clip, and we'll actually manually assign it here. We didn't do that last time. We used code to assign it, and the reason for that is because we had multiple clips for a single object. Right now, we have just one sound effect. Might change it in a later one if we give Qbert other sounds, but in this case, we will just give him one assignment, one clip assignment. So what we do, we will, for Qbert, some of this will look familiar since we just did this. So public audio source, and we'll call this fall SND. Actually SNDS since it's the audio source. And again, we don't have to do individual clips because there's only one sound that's ever going to be played, at least at this time. So we go back to Unity. We go back, so Qbert's selected. And again, we take the audio source and assign it to the audio source. And then we just need to play. And we already have the section where Qbert is colliding with the net. And so we can just, and we said it was fall sounds dot play. Did I shut off I did not shut off play and awake. Okay, so sorry for a little bit of jumping around there, but again, we basically just did what we did a few minutes ago again, although simpler actually because we didn't need the individual audio clips since we only have one. So what this should do is when Qbert collides with the net, you should now hear that sound effect play. It's not perfect because the sound should really play as soon as he starts to fall off the board, but you'd have to either add colliders or check for, if his velocity has increased. There's several ways to do it, but the idea is just the basics, the broad strokes of showing how to assign sounds to certain actions. And let's just have them jump off. And sure enough, when he went back there, it did play. Okay, so in this video, we are going to add a title screen, and we are going to use the UI object, and we will do a beginning introduction to how the UI works, and then that will lead into displaying high scores and things like that. So first thing, we're going to go up to File, New Scene. That should be familiar. We did that when we created the Game Over scene. Now what we're going to do, we go up to Game Object, we go to UI, and you've got one of two things you can do. If you create a new UI object, it will automatically create a canvas, or you can add that manually. As you can see, you can add that here. So we'll just add the object. We're going to do an image. One of the really annoying things about using the UI, at least I'm using in 2018.3, maybe they've changed it in the newer version, but the UI is scaled very differently. So like in the lower left corner here, that would be like your entire play area, and this scales out just enormous. You'll see that when we get into the other levels, but for whatever reason, it doesn't do a nice clean overlay. It does this huge scaling out for some reason. In fact, you can see the light here, and the overhead light, like I said, is usually above the work area. So that border, and you can see how enormous this is. Okay, so that's the default image, which we're going to replace in a minute. So I just want to mention that the reason why you have a UI layer is because it is a 2D layer that ignores the camera. So in other words, if you have a 3D world, no matter how much you spin around and rotate the camera, this stays centered on the screen. So it ignores camera rotation, ignores all that. So it's an overlay. That's one of the reasons why I argue that if you're making a 2D game, you technically don't need the UI layer because everything ignores camera rotation. There's some other complications though, because say your camera pans left and right, you could have an issue there, but that's a separate discussion. So anyways, so there is the image object. So if we select on it, and there it says image source, so we need a sprite. So this is the image that I imported. Again, I just drew it in an external paint program. I use Anime Studio version 11, and then you just drag and drop the final image into the asset area. So you just click on it, and we have to make a quick change. So texture type, we want to change this to Sprite 2D UI, and we really don't have to make any changes other than that. And we do apply. And see how you can now see a checkerboard in the back? That tells you that the background is transparent. And that's just one of the things that paint programs support. They support having a transparent background. It also handles translucence because you can see like the blur motion behind Qbert here. You can see that it's also somewhat translucent, but you'll see it easier when we put it on the screen here. So we just drag and drop that in. Whoops, sorry. Let me try that again with the image selected. So we'll drag Qbert there, and there we go. Now, clearly, completely the wrong scale. So let's do a few things. So we have the width and the height here. So we could do, say, width of 400. No, let's try it again. Let's try 900. That's better. And let's try height of 300, 400. It was kind of a rectangular image to begin with. That actually might look right. And so, like I said, you want to center this in the frame. Although for some reason, I'm not sure if it's because I have, when I'm running it in game mode, it's like in a free unlocked resolution that it doesn't line up quite right. But it will in the final build. So, let's just push that down a bit. So it's just supposed to be like him jumping off a couple of the blocks. Now we're going to add text. At the top is just going to say Qbert. That could technically be part of your image too. I just didn't, I figured I'd show you a couple examples of how to, different objects that you could add to the UI. So UI, text, and this will just be in the text section here. We'll just do, I don't think the asterisk will mess it up. And now we do font, like 60. And then we have to change the size of the rectangle. So that, again, would be right here. So let's see, 900 by 300. There we go. Oh, that's way too big. But we need Qbert to be bigger anyways. So we'll make this like a 90, 120, something like that. And yes, this is not really aesthetically appealing. I'm just, again, trying to demonstrate how to use certain objects. And in this case, there's really no reason to have to tighten up this border. You can, but in this particular instance, it really doesn't matter. Okay, so let's just run that. And there's got your title, you got your image, and what we're going to do, we're going to add a line of text, probably at the bottom here, just so things aren't overlapping, that says press enter to begin. So game object, again UI, text, push this at the bottom, and let's make this a little bit bigger. And font. And it's going to definitely have to be wider and probably a little bit smaller of a font. Let's try like 48. And it's still kind of big. Good enough. So press. We'll use space. So we'll push that down a little bit. Okay, again, aesthetically it doesn't look great, but again, the idea is I'm just trying to show you how to use different UI objects. Now, when you have UI objects, particularly if you're using buttons, they allow for clicking, but this particular game really doesn't have any direct screen clicking that's necessary, so we really won't review that in this particular demo. Okay, so now what we're going to do, we are going to save this, and we'll call it title screen. Let's now check for the pressing of the space button, and we'll use coding similar to what we used earlier to load the game over or to reload level 1. So we will go up to File, we will go to Build Settings, we will add the title screen, and in this case, we will put it at the top because, as I said, when this program gets executed, when you're testing it like this, whatever scene you're in, that's the scene it starts with. But when you execute, it is based on order here until some line of code says to jump around. So remember, the scene has to be in the build if you want to be able to navigate to it, which makes sense. So now what we're going to do, we're going to create a GM object. So game object, create empty, and again, GM, that's just for your benefit. It means nothing to Unity. And then we'll just right-click, create C#, and we'll just call this start menu. Whatever you want to call it, start screen. And then we'll click on the GM object. We'll put that there. And then we'll double-click. And basically, all we're doing is we're looking for input of the space key. So, if input dot get key down, I believe it's space in lowercase letters, and we have to, again, up here, let it know that we're using Unity Engine and scene management. And that unlocks or makes available the scene coding. So scene manager dot load scene, and it's level 1. Is it capital? Level 1 lowercase. Okay. Okay. So again, we are doing this in the update section because we want this to be checked with every frame. Input dot get key down, parenthesis, in quotes, the key that you're looking for, and then the squiggly brackets, and then what's being done. We're going to load level 1. Now let's test that, and then we'll do one more thing, at least for this scene. Actually, before I do that, let's make sure it's saved. I don't want anything weird to happen, just in case it crashes. And there we go. So now you have a title screen. But like I said, I want to add one more thing to it, because typically title screens have music. Not always, but they could. So what we're going to do is, on the GM object, we will give it an audio source this time, very similar to what we did in the last video. And I brought in this new file, again from Retro Sound Pack from Mululu. And what we'll do is we'll just drag and drop it here, and that automatically creates the audio source, automatically assigns the clip, and then this actually requires no coding. Remember how I mentioned about play on awake? Well, it defaults, which means as soon as the scene loads, as soon as this is instantiated, this will start to play, and then you just click on loop. And so you have the combination of this starting to play as soon as the scene starts, and when it reaches the end, it plays again. And then that will run this, and that should just about finish up the title screen. And we run it. And you should hear the drum beat playing in the background. No, it's not high-tech music or anything. The idea is, again, just for demonstrative purposes. Okay, so we know that that's working. We'll hit space. And that brings us to the main game. So you could do the same thing with the individual levels. So like with level 1, you could also attach an audio source with a clip to maybe the GM object within the level, and that way you have music playing in each level as well. So not going to bother showing that because it's identical to what we just did. So let's now move to level 1. Save that. And see what I mean about how you don't see your workspace? Well, I mean, this is the workspace, but you don't see the board. It's way the heck down there. Again, I have no idea why Unity insists on doing this. It's been like this since like version 5.4. But it's easy enough just to zoom back in. Okay, and I probably shouldn't bother lining this up too much because it's just going to be moved again when I add the UI to this layer. So, game object, UI, and we will do text. So you can see it there in the background, way, way, way out there. So we're just going to click on canvas. And this will be current score. So we're going to rename the text that. Now remember I said that for the most part order doesn't matter in the hierarchy. Within the canvas it does. So it probably won't be an issue here because we're not going to have a lot of images. We're probably just going to have regular score, maybe high score. We could put a player 2 there, but we really haven't added player 2 functionality. I suppose that could be one of the asks at the end of this series if you guys want to see how to do a second player for like couch co-op, that kind of thing. So it really doesn't matter what we put here because for the text, we're going to modify it with an attached script. Or to be more precise, what we're going to do, we have a script attached to the GM object, and we're just going to create a reference to the current score object. So let's go to our GameFlow script. And up here, we need to add using Unity Engine .ui, and just like scene management, that will make additional commands available. So public text, and we'll call it. Want to be careful using the same verbiage. So your score, and then txt at the end. Again, this is arbitrary. You don't have to do that. Again, it's just so when it pops up in the list, it tells me what I'm looking at, and that it's referencing out to a text object. So let's go back to Unity. So GM, and so there's the new reference. We just drag and put that there. And then it's just a matter of drilling down to that part of the component because you're drilling down. So this has the text component. So we want this to be checked on a regular basis. So we'll put this in the update section. So outside of the two ifs, you can either put it above or below. Doesn't matter. Everything in the update section will be executed anyways. So now what we have to do is first we have to say what object we're changing. So it's the your score text, and that's what I mean. I know I've said it before, but by seeing it in the list there, I know that that's the text object. So your score.text .text equals, and we will set this to, we have total score. Actually, yeah, let's do total score. Now we may have to set that to string. Yeah, it doesn't like that. So to string. Sometimes you have to convert numbers actual into a string for it to be displayed in the text. And I think that's all it's going to take because we created the text object The text object is being modified by the GameFlow script, and we are putting the total score in there. I think that should do it. So now we just move around. There we go. It's really tiny. I'll fix that in a second, but there we go. We now have on-screen scoring. So actually, we want to do that here. So current score, and we'll make that, like I said, we have to make the size of the rectangle around it bigger. And let's see how like a 32 font looks. This is what I mean about it not looking like it's lining up correctly. But again, I think it's because I have a non-standard size running there. But just so it looks right in this particular demonstration, we'll move it. There we go. We have on-screen scoring. Okay, so in this video, we are going to look at adding the disks that Qbert can jump on. So like there'll be like one here and one over here, and it will change from board to board. And he'll hop on the disk, and the disk will automatically bring him up, and then he'll hop off. Now, I just want to mention something. I might have referenced it in one of the earlier videos. Because the original Qbert was a 2D environment emulating a 3D environment, it could get away with a few cheats. So what would happen is the disk would be here, it'd move right along the side of the board, get to the top, and he would automatically drop straight onto it. It could do that because it wasn't really a 3D environment. For us, it is a 3D environment, so if the disk is moving like this, it is never above this. So what we're going to do is when it gets to behind it, we'll just have him automatically jump off. So not 100% identical to the original game, but close enough. The only other alternative is that once the disk got high enough, we then have to have it change trajectory above this and then drop down. So no matter how you slice it, it's not going to look exactly the same because, again, it was a 2D environment, and so they could cheat like that. So for our disk, we're just going to go to Game Object, 3D Object. We're going to go to Cylinder. And by default, a cylinder for its X and Z size, it's 1 Unity unit. So what you're going to see is it's going to basically be the same size as one of these. See how it centers nice edge to edge to edge? That's not a coincidence. So when you make an object, it's 1 Unity unit, and that's at least horizontally. Vertically, it's obviously much bigger. So again, that makes life easy if you keep using that 1 Unity unit measurement. So what we're going to do is the disk was technically the same height as the tile when Qbert jumped off it. Well, because we're using gravity, that's not going to work out right. So what we're going to do is we're going to use that same 1 spot over, 1 spot up. So 1 Unity unit over, 1 Unity unit up, just like these other steps. So it's like you're just adding a step off to the side here. So again, Qbert didn't have to do that because they were faking a 3D environment. So unless we want to bend the way physics works, suddenly we're kind of stuck. Something else I want to mention, these really don't have thickness, okay? These tiles, these planes. This does. So when you put this at, say, the height of -6, it's colliding at -6. If you put this at 6, it's the center. So you have to be very careful with your calculations. You might actually have to set this slightly lower than what you think you would have to. So let's just scale this down, and it needs to be fairly thin. And this is what I was talking about. So let's zoom in. So it's really thin, but the center of this would be at -6. So if we do that, since I don't have the horizontal right, it doesn't quite demonstrate the issue. But this one, it's the top. This one is the center. So you have to make these fairly thin to not mess things up. And even that, like I said, you're probably going to adjust this slightly so it's slightly beneath that. Okay, so now we actually want it to be the height of this one, which is actually -5, not 6. So we'll make that -5. And this probably needs to be a full 6x. So it's this one's horizontal, but this one's vertical. As you can see, basically what you've done is you've extended this layer out one. Now, this, for some reason, comes with a capsule collider. So this is round-ish. So if Qbert tries to jump on it, he'll just roll off. So the first thing we're going to do, we're going to remove that. So add component, physics, and we'll add box collider. So yes, it's a circle, but he's only actually landing on the dead center. So that's one of the reasons why we've been able to get away with box colliders in this. So we're just going to shrink the size. So 0.8, 0.8. And also, if we didn't shrink the size, you have the chance of it clipping as it's moving up. So, size should be approximately right. Its position should be approximately right. It's got one more thing that we need to do. Now, right now, it can't move. It doesn't have the rigid body. So, add component, physics, rigid body. We don't want to use gravity. We want it to just hover there. Because if we say use gravity, it's going to drop as soon as it instantiates. We are going to freeze the rotation because there is the potential for this to spin around. When Qbert lands on it, it could technically spin along the, I guess that would be the kind of the z-axis. Anyways, so we don't want that flipping around, so you can freeze the rotation. So not the position, the rotation, because we don't want this to rotate. Now, the other thing I'm going to do, I mentioned mass differential in the one of the previous videos because I talked about how to handle collisions between Qbert and Nerd and Blob, and that we didn't want Qbert to be knocked off kilter, and that one of the ways you could do it is by having a drastic difference in mass. So what we're going to do is, in this case, the cylinder, actually let's just rename that disk. The disk is going to have much more mass, so bump that up to like 500. And that's very important because we don't want this slowing down as it's moving up. So if I haven't forgotten anything, we can now have Qbert hop on this, and it should stay still. So let's run this just to make sure that what we've done so far is working. Good. And that's another case where you might want to have another audio sound that when he lands on this, it triggers a plane of a sound. As I said, I already demonstrated that in another video, so I think we can forego that demonstration. But we'll see. We'll see what you guys want at the end of the series. Okay, so far so good. The position is good. He lands on it. It doesn't knock it around. Now we need it to move. So this is going to look very familiar because at this point we're really not. The coding that I'm showing you is really just repurposing something that we already did. So I'm going to add velocity to this disk, and the velocity is going to occur based on a collision. So those two things are nothing new. Oops, sorry, didn't mean to click there. So create C#. We'll call this disk con. We'll open that up. Maybe. Now, since we're this far into the series, we'll just delete these. We already discussed that those are documentation only, and they just explain when these occur. So outside of start, outside of update, but within the public class, we want to do on collision enter. And again, because I'm using Visual Studio, all this other stuff gets populated. I don't like the word collision here. I think it's confusing, so we'll change it to other. And now we're just going to, we're not going to check to see what's colliding with it because technically nothing else should collide with it. Like we already set up the blobs, they can't fall off like the sides, they can only fall off the bottom. So technically there shouldn't be anything that can collide with this. If for some reason we do need to check, Qbert has a tag, but I'm not going to bother right now because we already looked to see how that did and trying to keep the code simple. So get component, rigid body, velocity, and it's new vector 3, and it's a -2 along the x, +2 along the y, and 0 along the z, if I have remembered this correctly. So we made the script, but we didn't actually attach it to the object yet. So let's click on disk. Let's put the disk on there, and now, based on a collision, it should stop moving vertically. We'll test that first, and if it works, then we'll do something up here to make it stop and then make Qbert jump off. There we go. And so when he reaches this point, he'll jump off automatically. So similar to the net, what we can do, we can put a collider up here. Obviously, it'll be much smaller. And then what we can do is when Qbert collides with that, he'll automatically jump off the disk. And we'll just have the disk self-destruct. So a couple ways we can do this. We kind of want the disk to stop moving because when he hops, we don't want the disk to trip him up. So let's see how this plays out. So first, we said we needed a collider up there. So let's do game object, create empty, add component, and it'll be physics, and it'll be a box collider. So let's move this. All right, so this one is 0, 0, 0. So we want it to move this way along the z-axis. So we want it to be positive along the z-axis by 1 and up 1. So it would be 0, 1, 1. Let's go back to our new game object, and we'll make that 0, 1, 1. Now, obviously, it's too thick because, again, 0, 1, 1 is the dead center. Right now, Qbert would hit it right here and then jump off. And the other thing we need to consider is the fact that Qbert's collider is not his entire body, so actually it's the bottom that would hit it. So first we're going to thin out this, and this time I will use the visual because there's no object getting in the way. You can see from above, it's positioned basically right. So about half a block more. Just thinking about, because it's like halfway up for Qbert. So let's do like 175. And 17. So now what we do is we want to check when Qbert collides with that. So we already have, actually I didn't make it a trigger, sorry. Let's go back for a second. Sorry for jumping around. That needs to be a trigger. So we already have we already have the on trigger enter, and it specifically checks to see if it's net. So we are going to have to give this a designation. So let's go to tag, add tag. We'll just call it top. And then we'll click on it again and choose top. So if other dot tag equals top, then we want Qbert to jump. We're also going to have to rotate him too. We want him to jump along the Z axis. So we want him to jump down this way. So we will just double check with the key check. So it was 4 up and -1. So do the same thing. Actually, let's just copy it. What am I doing? I keep saying it's rinse and repeat, so I'm also just copy it to reinforce that fact. So if he collides with top, he'll hop off. Because this is faster than what the disk is moving, I don't think the disk will trip it up. But if it does, like I said, we can have the disk self-destruct. Oh, there we go. I didn't think it worked at first, but it did. Let's run that again. Because it looked like he dropped straight down, but I'm presuming it's just that he hopped off screen. Actually, there's a better way to do this. We can just move the camera back a little bit. So main camera, we'll just move this back. Actually, we just move it up a little bit. So let's move it to say 2. There. That should let us see it. I was going to open another window, but this should suffice because it should be right about here when he jumps off. Sure enough. Like I said, he just needs to be rotated, and just like that, we added the disk. So another success, if I do say so myself. And we'll just copy the UA angle. We'll run it one more time, and then I think that will be it for this video. Because, well, the only thing is, this is only working for this disk. So we could put this disk, say, here, here, here. But the problem is, we would need to put another collider here, which we could, and then have it jump along the other side. So like right now, this one's called top. Maybe we could rename it to right and put one here called left. So yeah, so almost everything will work. You can just copy the object itself, but we'd have to put in a little bit of code to see which one he's jumping, which one he's colliding with. So sorry, I'm just kind of thinking ahead. Oh yeah, we put in the UA angle. Did I save it? Because I was chit-chatting. Yeah, no asterisk, so it was saved. You might have to tweak it ever so slightly to make sure that he's really centered, because I didn't really hop around to see if it caused the problem, but I think it's pretty clear what we're doing here. So he looks like he's slightly far back, so let's try hopping up. No, I think he's good. And sorry, a brief splice there. So, okay, I think that's it. Like I said, you can duplicate this object, put in a tile up here, and then just adjust the trajectory, the velocity of this, as well as have him jump in this direction rather than this direction, and it would be based on the tag that's being collided with. So if you want to see that, I can add it, but really you're just reworking what we just did. So I think that should about do it for this video. If there's anything else you want to see, let me know. It's funny, I originally said this series was going to be maybe 5 or 6 videos. Here we are on 11, I think. So it definitely went longer than I thought, but I think we really are close to the end now. The only thing we don't have the snake. That pathing will be a little bit more complex. And we don't have the guys who travel along the sides of the blocks. But everything else is pretty much there as far as having sound associated with events, changing the color of the tiles, scoring, loading a new board. So yeah, that should about do it. So I hope this was useful. And again, if there's anything you want to see, let me know, and have a good day.